diagrams need not be drawn to scale. Which means that don't assume that they're drawn to scale, but that's actually not the best option. And my moderator says I apparently didn't go live, but for some reason the software has a start streaming button and uh, start broadcast button. So I think that I am gonna pause for a second after I talk about the not drawn to scale to just discuss something quickly with my moderator and because live videos. And by the way, this is the first time that I do a live video. As many of you have already seen some of my Regents videos that are not live. This is my first one doing live, so I just got to discuss something. But about diagrams not drawn to scale. Doesn't mean that they're not drawn to scale. In fact, most Regents have 0 diagrams that are not drawn to scale. Some Regents have 1 diagram that's not drawn to scale. And I have seen a Regents with 2 diagrams that weren't really drawn to scale. I have not seen a single Regents in algebra, geometry, and algebra 2 since high school. When I was in high school, and I'm not in high school anymore, since I was in high school, that had 3 diagrams not drawn to scale. Literally maximum 2 not drawn to scale. I've and that's extremely rare. I've seen it 2 or 3 times. I think 3. I've seen 1 diagram not drawn to scale maybe 20% of the time, and most Regents have no diagrams drawn to scale, not drawn to scale. So assume that they're drawn to scale if you have no clue how to do the problem. That is the best advice that I can give you for geometry Regents, more than anything else. And I know a lot of teachers hate hearing that, but I just want to make sure that's clear. So I'm going to ask my moderator something real quick. Did the video start mid problem 1 or at the beginning? So this is my first, as I said, this is my first live video. So that's why there's gotten to be a little bit of bugginess, and I hope you guys tolerate it. I really appreciate you sticking around for a random text from my moderator. My moderator's name, by the way, is Jelly. So if, her nickname for video purposes is Jelly. I'm Peanut Butter. That's why she's Jelly. So if you are in the chat, please do say hi, Jelly. So I'm going to start with problem 1 right away. Which expression is equal to sine 30? Is it tan 30, sine 60, cosine 60, or cosine 30? And like I said, I'm going to give you 1 minute to do the problem. Okay. And my moderator does tell me that my video started mid-sentence, so I'm going to redo a little bit of my introduction after this, but I already started with problem 1, so I'm going to give you a minute to do this problem. Again, in the chat, please do say hi, Jelly, if you see it. Or in the comments, say hi, Jelly, and she'll appreciate it. Got about 30 more seconds. Don't be afraid to pull out the calculator. There's nothing wrong with pulling out the calculator. "11 seconds, and then I'm going to get started on how to do this problem. Okay, so how to do this problem. First off, let's talk about how to set up your calculator to be in the correct mode. This is a geometry region, so you actually want to be in degree mode. Okay, so if you scroll down to the mode, radian versus degree, you set degree mode, press enter. Okay, there is no stats, so we don't have to worry about diagnostics on. But if you are taking a test that has diagnostics, you go to the catalog, which is right above the 0, and you scroll down to diagnostics on, and you press enter twice. If you can't find a function somewhere in your calculator, by the way, the catalog has every single function. So why am I mentioning the calculators right now? Well, because this problem can be done on the calculator. So I'm going to use my random number generator to choose one of the random choices to just test it. If you have a favorite choice, if you do that, if you think it's right, do that. So, but the calculator will tell you what the right answer is. Sine of 30 is 0.5. And then this one told me to test choice 3, cosine of 60. Hey, what a coincidence. Cos 60. Or you just go 1, 2, 3, 4, or whatever you think might be the right answer. This one is, a lot of students unfortunately do get it wrong, but it's a gimme problem because literally, give me the answer. There it is. There's your answer. Which one's equal to sine 30? Cos 60. And just to make sure, I'm going to test sine 60, just to make sure that it's not the right thing. They're not the same. So now we know that this is the correct answer. Okay, there is some process of elimination that we can do. First off, this is sine of 30. So the chance of between 0 and 90, sine and cosine match in exactly one place. Sine 45 equals cos 45. Okay, and that's the only place between 0 and 90 where sine and cosine match. So sine 30 cannot be equal to cosine 30. Okay? Sine of 60 doesn't match with itself anywhere between 0 and 90. In other words, between 0 and 90 degrees, sine of theta is 1 to 1. So that can't be it. And it does turn out that tan 30 and sine 30 only match in one place. Tan 0 equals sine 0. And this is equal to 0. And just for completeness, sine 45 equals cos 45 equals radical 2 over 2. Okay? So this one is also not the answer. So the only one that's left is cos 30. Cos 60, rather. Again, this is a calculator problem. This is a gimme problem. Don't be afraid to do a problem using the calculator, but also don't be afraid to do the problem in any other way. Like this, for example, this is the classic 30, 60, 90 triangle. That's what sine 30 actually corresponds to. So if this is 30, if this is 1/2, this is radical 3 over 2, and this is a 1. Or equivalently, I know a lot of teachers like it this way, with a 30-degree angle, and of course a 60-degree angle here. Some teachers like writing it this way, radical 3 and 2. And then some teachers even like putting an x in front of it, which I actually advise. So if you're the kind of teacher who puts an x in front of those, you did a good thing, because unlike before with just the 1, radical 3 and 2, you can only do a little bit of calculation with it, meaning multiplication and division. But with putting the x there, now you could do addition and subtraction as well, if necessary. So that's how to do this problem. Again, my moderator had told me that my video started mid sentence, so I will go back and just do a little bit of my introduction before going to problem 2. Again, my name is Juan Tutors. And I'm covering the geometry regions. Quick, if you want to go to get some tutoring, go to JuanTutors.com. I don't want to harp on that too long because I did do it before, and we're already getting started, and students are not totally interested in that. You are more interested in getting these problems correct. So I am going to hop right over to problem 2. And again, I'm only going to have a very short ad somewhere in the middle of this video, and it may be just very quick, mentioning my tutoring company, but that's it. Number 2, in the diagram below, SRA. Oh, I did remember what I was going to say. I'll say that during the pause. In the diagram below of a triangle SRA, KP is drawn such that angle SKP is congruent to angle SRA. Now, just basic test taking strategy. If they tell me that SKP is congruent to SRA, I'm going to label those as congruent, 1 dash each because they're congruent. If SK is equal to 10 and SP is equal to 8 and PA is equal to 6, what is the length of KR? So they want this line, KR, to the nearest 10th. Okay, pause. I'm going to give a little bit more of pause. So more than a minute, because I want to talk about what my plan is for this video. Because I don't know exactly where I got cut off in the beginning. First live stream, so that's kind of the kind of thing that happens. But I said that I want to make this just the absolute best Regents prep video possible, and what that means is I know that a lot of Regents prep videos tend to be like 2.5 hours long because the Regents prepper literally gets onto the video and just starts doing problems, and you just kind of hope that things are going to absorb. But the truth is that's how a lot of instruction is done throughout the DOE or throughout school, and that's how you're expected to learn. If it hasn't worked for the last 11 years, is it going to work now? I think that it can work, but I think the right way to go about it is to take some time to actually practice the problem, um, and take some time to practice the problem and uh, do what you can do uh, to get as many points in as possible. So now for this diagram, for this problem, and the time is up for this problem. If you need to take a little bit of extra time, I do want to talk about what you might want to do. You have KR, your goal is to get the value of KR, right? That is your goal. Well, if your goal is to get the value of KR, then uh, you might ask yourself, is there anything that we can do to estimate the value of KR? Is there anything that we could do to eliminate any answers? Is there anything that we could do that we remember in terms of any theorems that allow us to get the value of KR, or at least partially get the value of KR? You never want to get to a problem and say, I don't know what to do, and then do nothing. Because a lot of times when you say, I don't know what to do, what you mean is that right now, I don't know what to do to get to the exact final answer from start to finish in one step often. This is not, geometry is not a one-step math. Geometry is a multi-step math. It takes a lot of steps to get to a final answer. Now, this is the first diagram that I want to talk about scale. Okay? Now, what is scale? What is scale? So drawn to scale, what that means is that objects look proportionally the correct size. So here's an example of something that's drawn to scale. See this line segment? I label it 8. And this line segment right there. Ooh, that one came out really straight because of the software. I'm going to label this as 15. So notice that the one that says 15 is longer than the one that says 8. Not only is the one that says 15 longer than the one that says 8, it's just barely a little less than twice as big as the 8. And 15 happens to be a little less than twice as big as 8. So this is drawn to scale. Okay? What about not drawn to scale? So what about this line segment? Okay? If I draw a triangle, okay? Now I see that the bottom side here, now these did not come out straight because the software didn't make them straight. But if I label this triangle 5 and 12 and 13. Now I see that the bottom side is labeled 12. Now I and you, when you're drawing your own figure, don't assume that your own figure is drawn to scale because you just drew it. You should not necessarily assume that the figure I drew is drawn to scale. I'm talking about the figure that the computer programmers wrote for the problem. Is that one drawn to scale? So this 5 and this 12, this does not look over 2 times as long as 5. So this is not drawn to scale. Okay, this is not drawn to scale. Got it? Move this coffee over here. Okay, so this is not drawn to scale. So what about this diagram? If we look at the 10, the 8, and the 6, well, let's see. The 10 is longer than the 8. The 8 is longer than the 6. Now, the question is the 8 just a little bit shorter than the 10? Yes. Is the 6 a little bit shorter than the 8? Yes. The 6 is almost half of 5, but not quite. Does the 6 look a little less than or close to half of the 10, but not quite half of the 10? Yeah, it actually does look like The 6 is just right. The 8 looks just right. The 10 looks just right. And also the congruent angles look like they're literally the same size. So this is drawn to scale. I'm going to use the letters DTS. So I'll say drawn to scale, but I'll write DTS. DTS, drawn to scale. So what that means, how can we use that to guess at the value of KR if we just don't remember how to do the problem? Well, since it's drawn to scale, the KR looks like it's less than the 10. So any answer that's less than the 10 is likely wrong. So let's talk about my notation for marking things wrong. I put an X next to something if I think it's wrong. And I'm going to talk about thinking it's wrong versus knowing it's wrong. But also the KR looks looks longer than the 6. So the 4.8 is probably wrong. If I assume it's drawn to scale. Now, let's talk about assuming it's drawn to scale versus confirming it's drawn to scale. We actually did confirm that it's drawn to scale. The 10 is longer than the 8. The 8 is longer than the 6. The 6 is slightly more than half of the 10. It looks it, and the number is it, and the angles are congruent visually. So this diagram is drawn to scale, which means that we know that choice 4 is 100% wrong. So I cross out the answer at the choice when I know it's wrong. I cross out the answer next to the choice when I think it's wrong. And then I know 4.8 is wrong because it's drawn to scale, KR has to be longer than PA. And in fact, it actually looks really close to KR. So maybe 8.0 is attractive as an answer, but 7.5 is also very close to 8. So I can't eliminate either 2 or 3. So how did I go about this problem? There's something called the side splitter theorem. The side splitter theorem, which by the way, there's a triangle later on that we unfortunately cannot use the side splitter theorem that is reminiscent of this problem. And then we're going to use similar triangles. So we're going to use the side splitter theorem. So let's talk about similar triangles. So the top triangle, so this KP is parallel to RA. The reason I know that these two are parallel is that we have two lines with a transversal SR and corresponding angles are congruent. When corresponding angles are congruent, the two given lines that the transversal crosses, the two given lines are parallel. So these are parallel, which means that the side splitter theorem applies. You could also use equivalently that the top triangle and the whole big triangle are congruent. But the side splitter theorem implies that the top half of SK divided by the bottom half of SK, KR, that's equal to the top half of SP divided by the bottom half of SP, PA. And we put in some numbers here. We have SK is 10, divided by KR is unknown, which is what they want us to find though. And that's equal to SP, 8, divided by PA is 6. And now we can cross multiply. And we already see that KR has to be shorter than 10 since 6 is shorter than 8. But I know students love the cross multiplication. 10 times 6 is equal to 8 KR. Divide by 8. Divide by 8. And you can do the simplification on your paper, but I actually suggest going to the calculator, so I will simulate that right now. So 10 times 6 divided by 8. Okay. Let me turn off this math software to speed up my computer. Okay, so we got KR is 7.5. So that is 100% correct. All right, cool beans. All right, so this next problem, I see another diagram. We could ask about drawn to scale. Those questions are definitely relevant. I'm going to give you again a minute to try to solve the problem. But number 3, a rectangle is graphed on the set of axes below, and this is the rectangle, and it definitely looks like a rectangle. And that's the only part of it that could be violated. Does it look like a rectangle or not? A reflection over which line would carry the rectangle onto itself? Reflection over the line y equals 2. A reflection over the line y equals 10. A reflection over the line y equals 1/2 x minus 3. or reflection over the line, y equals negative 1 half x plus 7. So take your minute, think about the problem. I'm giving you a minute to practice. If you are watching this video after the fact and you really don't want to take the minute to practice, which again, I highly suggest you do, then you know what? Go ahead and don't take that minute. But again, I highly suggest you do. I'm really trying to create the best video possible for our practice Regents, and that includes giving you practice time. So take that practice time. "22 seconds left. If you haven't started yet, my suggestion to you is to think about drawing a diagram. If you have a printer, by the way, maybe I'll say this at the beginning of the video next time. Print out the test and do the test with me if you have a printer. If you don't have a printer, you might have to do a facsimile of it or something like that. That's the minute. So if what we do here, the way I suggest doing this problem, so we're going to reflect over which line to carry the rectangle onto itself. So I actually am going to draw the lines. The thing is that there's really no way of doing this problem without using the graph. This didn't give us any coordinates. It literally just gave us the problem, the rectangle on a graph. So how else would you do it? So I'm going to graph y equals 2. And that one already looks good. Okay. I'm going to graph y equals 10, 4, 6, 8, 4, 6, 8, 10. So I'm going to graph y equals 10. This is y equals 10. Okay. I already know that that one's wrong. And choice 1 is looking very good. And they did say would, right? Choice 1 is looking very good. Let's see choice 3. Y equals 1 half x minus 3. So we'll start there and go up 1 over 2. Up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Now, I know I'm drawing this by hand. Now, that's why they put it here, because it goes through the corner. I know I'm drawing this by hand, but we're going to talk about how to draw to get full credit on the test tomorrow, all right? So let's see, 1 second. I want to actually expand this. I want to expand this a little bigger to get a little bit more space to work on. Okay, so I see why they added that one. Maybe that one looks good to you. It doesn't look good to me. Y equals negative 1 half x plus 7. Okay, so here's 7. Oops, I went off a little bit on that one. So this is another one that's going to go through the corner. Now, you should have a straight edge with you. I would suggest drawing this with a straight edge during the Regents. If you're home and you need a straight edge, remember, we rarely, but not never, we rarely actually need the actual ruler with the actual measurements to do this problem with a straight edge. I have seen problems where they literally require you to use the ruler, but it's almost never. Now, here's the thing about choice 3 and choice 4. A lot of students think choice 3 and choice 4 look good. There's a reason, there's a clever, logical reason that you could actually eliminate choice 3 and choice 4. And the clever, logical reason is this. Choice 3 and choice 4, if one of them is true, the other one also has to be true because they share the same properties. And there can't be two different answers. These are eliminable because they're identical in structure. They're obviously not identical physically speaking because one has a negative slope, the other one has a positive slope, but they have the same effect on the rectangle. There can't be two answers, therefore they're both false. So if you had choice 3 and choice 4, you know what? You made the effort, cool, but what ended up happening was maybe you got tripped up by asking the question, not which reflection would carry the rectangle onto itself, but which line divides the rectangle into two congruent pieces. And choice 3 and choice 4 do divide the rectangle into two congruent pieces. But the reflection, for example, by this multicolored line takes this point here, down here, down up here, and down to somewhere over here-ish, which is not on the rectangle. And then this point over here gets reflected to somewhere over here-ish. That one I just did a rough graph, but that point is not on the rectangle. So the multicolored line does not reflect the rectangle onto itself. Okay. You're welcome, Laura. It's great seeing you here. I see you. I see your comment. Next one. So number 4, número 4. The surface of the roof of a house is modeled by 2 congruent rectangles with dimensions 40 feet by 16 feet, as shown below. Roofing shingles are sold in bundles. Each bundle covers 33 1/3 square feet. What is the minimum number of bundles that must be purchased to completely cover both rectangular sides of the roof? 22, 39, or 4. So definitely highly recommend, again, taking your minute. I am going to give you the minute to practice right now. Think about eliminating answers. If you don't know how to do it, a range between 2 and 39 is an enormous, enormous range. So you may be able to eliminate some of these answers. That's a range of like 20 or 19.5 times, or also known as 1950%. That's a huge range. So take your time, try the problem, eliminate answers you know are wrong, and think about what you think is wrong, and then from there, maybe make a guess. Also, just try to do the problem, because you may find that if you think you don't know how to do it, but you actually just start the problem, do what you can do what you know is true, you may find that you actually know how to do it. Five seconds. Okay, so I just mentioned something that a lot of students do incorrectly. A lot of students incorrectly think that they don't know how to do the problem. Then they start trying to get clever ways of doing the problem, when in fact, often students just totally do know how to do the problem. They just convince themselves that they don't, because they don't know how to like finish it in their heads. They think that it's a one-step problem. Regents problems are not one-step problems, especially geometry. Geometry has a special property that you actually have to take theorems from multiple places within geometry often to get a final answer. The area problems, congruent theorems, and I mean, any kind of theorem that you could think of often bleeds into many geometry problems. Whereas algebra, it's like, do the inverse operation, do the inverse operation, do the inverse operation. Oh, there's some like terms. Oh, that's a surprise. Inverse operation, inverse operation, inverse operation, inverse operation. Oh, you have to cancel something from both sides equal time. Okay, inverse operation. Like, it's just that. Like, it's just over and over the same thing. Or substitute. You know, like, it's literally, that's how algebra works. You just do until you're done. Geometry, well, also you do until you're done, but you just take theorems from many different places and put them into the problem. So I would advise you to just start the problem, see what you can do. It's almost a guarantee that if you can do something, it is in the correct direction. I've had students who got a 40 on a practice Regents work with me for 1 hour and get an 80, because I just get them to just do something. And that's literally it. Do something correct. Do something correct. So the surface of the roof of a house is modeled by 2 congruent rectangles with dimensions 40 feet by 16 feet, as shown below. The roofing shingles are sold in bundles. Okay, so now the dimensions of, so each bundle covers 33 1/3 square feet. What is the minimum number of bundles that must be purchased? Well, clearly we need the area of the roof, right? So the roof is modeled by 2 congruent rectangles that measure 40 feet by 16 feet. So the area is equal to 2 times, parentheses, 40. This is base times height. So the area of a rectangle is equal to base times height. So this is equal to the 40 times 16. Okay. So, and then I advise you, you don't have to A lot of very high level students have been trained to not use their calculator so much so that they actually get questions wrong, and that's kind of a shame, because the truth is, if you can get the question right by just using a calculator, just do your arithmetic on the calculator. If you struggle with arithmetic, just always do your arithmetic on the calculator. And if you don't struggle with arithmetic, then do what I call predict but verify. Predict but verify means I think the answer is 1,280, and it turns out that I'm right. If you struggle with arithmetic, you're not going to guess 1,280. Now, the way I did, by the way, guess that. The reason I guessed is 2 times 16 is 32 times 4, right? 1, 2, 8. So 32 times 4 is 128. So multiply by 10, 1280. So so I did do the arithmetic in my head, but that's not something that everyone could do. That's something a lot of students could do, but not even 30%. And if you are good at it, you might as well just do the arithmetic on the calculator anyway. So the area is 1,280. Now, each bundle covers 33 1/3 square feet. Now, based on that, I know if the area is 1,280, suppose I'm a struggling student and I don't know what to do now, but I do know if one bundle covers 32 1/3 square feet, I can't cover over 1,000 square feet with 4 bundles, nor with 2 bundles. Okay. Now, if you have some quick estimation skills, just multiply 33 1/3 by 20 and 39 and see which one actually makes sense. And you might actually find out that 39 can't be the answer either. But how do you get the final answer? You do 1,280 divided by the area of a single bundle, 33 1/3. And we'll talk about how to put that in the calculator. And on this point, I'm going to note, a lot of students are surprised, a lot of teachers were surprised at the types of questions that are given on this Regents. And there is a thing that has been said for every 10 years or so, every 7 to 10 years or so, when they just suddenly decide that the curriculum needs to be changed again. And what they say is that when they're changing the curriculum, and so they're changing the Regents, a lot of times, a lot of people have these like favorite problems that they've been dying to put on the Regents, or they try to get clever with the problems that they put on the Regents because it's one of the last Regents. And so the problems start looking a lot different near the end of an old Regents while transitioning to a new Regents. And this one is an example. So how do you put 33 1/3 on the calculator? You do 33 plus 1/3. And of course, I forgot my division. Divided by parentheses 33 plus 1/3. Yes, you do need parentheses. Lots of students get this question wrong just by not putting the parentheses, or questions like this wrong without putting, because they didn't put parentheses, although you actually get lucky in this case. And I messed up because I didn't look at my notes. I said that 39 might be wrong, but I didn't do this by an estimate. I mentally I said 39 might not make sense. Hey. So I said 39 might not make sense, but the truth is that if you actually do the calculation, 33 1/3, that times 3, that was silly of me, wasn't it? Is equal to 100. And then 100 times 10, 100 times 10 is equal to 1,000. And so we're already at 30. So the answer is greater than 30. So that was a bit silly of me. But I didn't look at my answer before I said that 39 is too big. In fact, 20 might be too small. What did I just do? Now I got nervous because I got something wrong on a live video, so I got the answer wrong twice. So the answer is 39. Okay, that was fun. But let's go to number 5. Okay. So which equation represents a line that is perpendicular to the line whose equation is y minus 3x equals 4? Is it y equals negative 1/3 x minus 4, y equals 1/3 x plus 4, y equals negative 3x plus 4, or y equals 3x minus 4? So take your minute, graph it on the graphing calculator, okay? And I promise I won't make any errors from now on in terms of the choice because I will look at my answers. But you got 52 seconds left to do this problem. Okay? 43 seconds now. Got 33 seconds. Think about not just how to do the problem, but also process of elimination. But also think about how to do the problem. Okay? 23 seconds left. 14 seconds left. Think about you could graph things on your calculator if that's something that works for you. Okay, so about what just happened here. That's going to be where I'm going to put my ad. Sorry about that. I did not mean to have to. Okay, so I wanted to talk about this, about showing work. You might notice that I've been showing a lot of work. I'm writing a lot of explanatory work when I'm explaining this work. But here's the thing. This is what the blank Regents looks like. This is what a blank Regents looks like. And the reason I'm showing you what a blank Regents look like is that this is often what a submitted Regents looks like. Now, you know that we do not grade your work on a multiple choice question. Here's the problem. If the lesson that you take from that is that you don't have to show work on these problems, that's the wrong lesson. You're not going to figure out how to get the best grade possible without showing work on these questions. That's not a thing. So if you've been training yourself to not show work on problems over and over and over for the entirety of your high school career, it's not going to work out. You're not going to get the best grade possible. Every test that gets a good passing grade has work. And I think one of the reasons why teachers say focus on the multiple choice, unfortunately, is that students refuse to show work on questions. And then what ends up happening is that they're not able to get points on the part 2s, 3s, and 4s because the part 2s, 3s, and 4s require work. And that's it. But the thing is that your grade will boost like crazy if you show work on these problems. Okay? So number 5, numero 5. So what equation represents a line that is perpendicular to this line with equation y equals negative 3x plus 4? If you don't know how to graph this line, what you do is you solve for y plus 3x plus 3x, and you get that y is equal to 3x plus 4, and then you graph this line. You can graph that line. So you go to your calculator, you press y equals. Okay, let's clear this a little bit. That's from another Regents that I was doing. Y equals 3x plus 4. And then you choose one at a time, one of the graphs until you find the one that's perpendicular. I'm going to choose a random one, whether it's correct or incorrect. I use my random number generator to try to graph choice 4, y equals 3x minus 4. And they said perpendicular, so let's graph these. Zoom standard. This one is y equals 3x plus 4. And that's why these are parallel. That's y equals 3x minus 4. So these are parallel. So that's definitely not the right answer. Okay. Another thing that you could do is you could just create a quick graph of these. So here's 4. Y equals 3x plus 4 has a tall slope. Y equals 3x minus 4 goes through here and it also has a tall slope. So these are not perpendicular. Y equals negative 3x plus 4. Now these cross, but notice that negative 3x is a tall slope also. These do not make a right angle. So perpendicular lines form right angles. Okay. And then this one, y equals 1/3 x plus 4, goes through this, but also, now I'm going to switch colors to be able to see a little bit better. Y equals 1/3 x plus 4. Now I'm going to just redraw the line that we're looking at in red. This is the one that nope, that's not the one that we care about. That's the one that we care about. Now the red line and the blue line are not perpendicular, so we could actually also eliminate that. And so the only thing left is the y equals negative 1/3 x plus 4. And in fact, if we do that, the red line versus, oh, minus 4. The red line versus this multicolored line. They seem to make right angles. So I'm liking this one. So how do we do this? Perpendicular lines form right angles. But there is a theorem to know. So perpendicular lines also have slopes that are opposite reciprocals of each other. Okay? So opposite reciprocals of each other. Well, this slope has is 3. So the slope of the perpendicular line is going to be the opposite, negative, of a positive number, and the reciprocal of 3 is 1/3. So the only one that has a slope of negative 1/3 is choice 1. So we've confirmed that choice 1 is definitely the correct answer. And notice there's a lot of work here. There's work here. There's work, put up the calculator. There's work here on the calculator. Yeah, and notice I only graphed one of them, but the point is, go ahead and graph the other one too. Negative 1/3 times x minus 4. Compare that one to the blue one. Now, if you know that perspective is unfortunately skewed, so they don't necessarily look that perpendicular. Although if you're so used to looking at a calculator screen, they might look perpendicular. But if you do zoom square, now that everything's drawn proportionally, here's the first line that's parallel. That was choice 4. Now here's choice 1. Choice 1 is definitely perpendicular to the blue line. They make right angles. What did I do again? Zoom square to get everything graphed nice and proportionally. Okay? So there's work there, there's work here, there's work here, and there's work here. You can't really get through these problems and expect a high grade if you don't show work doing things that you know to be correct. Again, focus on correct math. This is another problem you could ask about scale. Ask about scale, and if you don't know how to do the problem at all, ask about scale and then do what you can to get the correct answer. So let's read it. A vertical mine shaft is modeled in the diagram below at the point on the ground 50 feet from the top of a mine. So they label it here 50 feet. Okay, a ventilation tunnel is dug at an angle of 47 degrees. So we see this ventilation shaft 47 degrees. What is the length of the tunnel to the nearest foot? Okay, let's get you that minute. Okay, and take your time, eliminate any answers that you think are wrong, that you know are wrong. Use scale. Use scale. I can almost I can get down to 2 choices just by using scale. And if you got a 50% chance, let's talk about 50% chances after this time. Okay? Got a 50% chance of getting the question right. 33 seconds. Okay. So I put a note for myself that just says to me, talk about 50%. Another reason why teachers tell you to focus on the multiple choice, or even students tell you to focus on the multiple choice, again, it's bad advice. I don't want you to think that's good advice. Unfortunately, teachers who are telling you to focus on the multiple choice have only started saying that when they've really fought you on showing work, and fought students on showing work, and students just constantly refuse to do it. There's a culture along of not showing work among high schools, and that's not true about any area of the country. That's true about literally the entire country, maybe even the entire world. But what ends up happening once we know you're not showing work, then what are you going to do with the part 2s, 3s, and 4s where they require work? So, but if you show work, your grade is going to blow up. Just showing work, even when you don't know how to do the problem, makes your grade blow up. And we'll talk about that. But talk about 50%. Why am I talking about 50%? Because you only need approximately 50% of the questions correct on the multiple choice to pass. If you get more than 50% by showing work, then your grade gets boosted like crazy. If you start showing work on the part 2s, 3s, and 4s, then your grade gets boosted again. So why is the 50% thing significant? Well, here's the thing. They want the length of the tunnel to the nearest foot. If we look at the scale, nothing violates this 50 feet length. So this is drawn to scale. The angle 47 degrees, that makes this angle 43 degrees, which is only slightly smaller than 47 degrees. And this angle is a right angle. It looks like a right angle. That's great. So this diagram is drawn to scale. Drawn to scale. So we can use scale to estimate the length of the tunnel. If this is what 50 feet looks like, okay, then that here is what 50 feet looks like, okay? If I had to visually approximate that. This length, therefore, has to be actually quite a bit bigger than 54. Now, we confirmed that it's drawn to scale. So we're not guessing that it's drawn to scale. If you're guessing that it's drawn to scale, you put an X here. Well, first off, you could put an X here because it can't be 47. It has to be longer than 50 because it's a hypotenuse of a right triangle. But if you're guessing that it's drawn to scale, then you could put an X here. But look at us confirming that it's drawn to scale. So we know that 54 is wrong. And now 68 or 73 are so close to each other that I can't determine visually which one might be wrong. But I see that this is the 47-degree angle. This is the side. The 50 is the side adjacent to the 47 degrees angle. And this is the hypotenuse. And that the one that they want is the hypotenuse. And we know that adjacent over hypotenuse is equal to cosine of theta. So the adjacent side, which is 50 over the hypotenuse, well, that's equal to cos 47. Now, I know students love the cross multiplying. I used to not be a fan of the cross multiplying when there were other ways of doing it, but I realized over time that it's actually cross multiplying fixes a lot of cognitive dissonance issues, or rather dodges a lot of cognitive dissonance issues. So if I cross multiply, I get more students to get higher points. So go ahead and cross multiply when it's appropriate, and it's appropriate when there's an equal sign. So we got 50 times 1 equals the hypotenuse times the cosine of 47. And now we got to divide by cosine of 47. Let me make that look like a cos 47. So divide by cosine of 47. Okay. So we get 50. We get the hypotenuse. And now I have another strategy that adds the tiniest amount of work to your workload, tiniest amount, but actually increases points. It's a rounding issue that a lot of students have. So I'm going to close this. I'm already in degree mode. 50 times 1 is 50 divided by cosine. So let's put the times 1 divided by cosine of 47. So the advice that I'm giving is for the part 2s, 3s, and 4s really, but I'm giving it now. Okay, let me see if I could drag this over. So I get this answer, 73.3139598. My advice is, this is a new strategy for me. I don't know. I haven't tested it, but I think it's going to work. I have a lot of strategies that I work with my students on, but I think this one's going to work. Write the full answer unrounded, and then look for the rounding that they want and give the rounding that they want. They said the nearest foot, 73. 0.3, 0.3 rounds down. So 73 is our answer. Okay? And that's what I'm going to do for the part 2s, 3s, and 4s to maximize the work. Laura says, not in DR, we showed work. And I didn't want to say that. I was born and raised in the United States. I was born in Long Island. But I have a lot of family members. And first off, in my school, we showed work, or at least I felt like we showed work. Maybe I was the only one who showed work. I don't know. But in Dominican Republic, oof, all my friends showed work. All my friends did. Every single one. I was amazed. I was like, why are you showing all this work? But like in my mind, I showed work too. I guess they just showed a lot more. So shout outs to Laura again. Number 7, número 7, on the set of axes below, triangle BLU has vertices with coordinates B, -3, -2, L, -2, 5, up here, and U, 1, 1. What is the area of triangle BLU? 11, 12.5, 14, or 17.1? I love this question because it's not a gimme at all, But there's a lot of ways to do it, and there's a lot of ways to estimate the answer. So I'm going to give you the minute. Take your time. Try to see if you can figure out something to eliminate some answers or to at least estimate the answer. This is a very estimatable problem. I'm just putting that out there. 48 seconds. Do what you can. Do what you can. And by the way, if you want to comment anything, please do feel free to comment. I will say this: the comments are about 30 seconds delayed, so I unfortunately will not see them usually on the at the exact time that you type them, but I will see them. Okay. And if you're not in the chat right now because you're not watching it live, then feel free to put any questions or comments in the comments section. Okay, and that is the minute. Okay, so this is a very estimatable problem. So we see some whole squares in there. 1, 2, 3, 4. That's the entirety of the squares that are not cut off a little bit. But there's some semi-legal gluing together that we could do. This one's missing a piece, but this one has a piece that almost looks like the piece that's missing. So if we count that as 5, if we put these together, put those as 6, put this and this together, make that 7. Let's see. Put this and that together. I'll call that 8. That's put that and that together, 9. Put that and that together, call that 10. And now, put that. That's almost a whole one, almost 11. And then that, 11 or 12.5, they both sound reasonable to me, but I think I just passed 11, so I'm liking this one. I'm liking that one. And I think that this one's wrong just by estimating, but it can't be, because of my estimates, it can't be 14, and it can't be 17.1. Now, if you don't like the way I estimated, or if you struggle with the estimating, maybe 14 was close, so you didn't want to completely eliminate it, but maybe 17.1 is actually just too big. So now you know how to estimate this question. And honestly, I'm going to erase now. Honestly, like, that was a pretty good estimating strategy. Now, there's 2 ways to actually get the actual answer. I'm going to do one of them, but I'm going to give you the other one. So if I draw a line vertically down, and I draw a line horizontally, okay, and then I draw a line there, I've split this triangle up into 3 triangles. All of them have a either horizontal or a vertical base, which means that the height is perpendicular, vertical or horizontal. So you can get the areas of each of these triangles and then add those up, and you have the area of the triangle, of the full triangle. That's a great way to do it. And I don't think it's harder or easier than the method that I'm going to use. But the method that I'm going to use, I'm actually going to draw a rectangle around, and this is method 2, around the triangle. Okay, didn't want to straighten that one for me. There we go. So I'm going to draw this rectangle around it, and now I got the triangle, the area of LBU is equal to the area of the rectangle minus the area of triangle 1. Call this triangle A. Let's call this A, B, and C. Area of triangle A minus the area of triangle B minus the area of triangle C. Okay, so the area of the rectangle got 4 and 7. So that's equal to 4 times 7 minus the area of triangle A. So 1/2 base times height. Let's talk about the formula sheet real quick. So just do remember that there is a formula sheet. Let's bring that over here. Okay, here is the formula for the area of a triangle. Area is 1/2 base times height. Now, conspicuously missing is the area of a rectangle, but it is a geometry class, and you are expected to know that a rectangle is a parallelogram, just that the angles happen to be right angles. So the area of a rectangle is right here. Area is base times height. Okay, so it is there. Area is base times height. So that's why the area of the rectangle is 4 times 7 minus the area of the triangle A, 1/2. Now this length is 1. This length is 7. This length is 4. This length is 3. This length is 4. And this length is 3. Okay, so the area of triangle A is 1/2 times 1 times 7 minus the area of triangle B, 1/2 times base times height. So this is the top triangle, 3, 4, minus the area of a triangle C, 1/2 times 4 times 3. Okay? And I would stick this into your calculator. You don't have to do the simplification on paper. This will confirm that the answer is decimal. Again, I would recommend sticking the whole thing into your calculator, but you get 12.5. Okay? So that's 2 ways of doing it and 1 way to estimate it. That's a phenomenal thing that we have. And the estimating strategy eliminated for sure choice 4 and likely eliminated choice 3. And we passed 11, so likely 11 was also wrong. But again, if you're not comfortable fully eliminating 11 or 14, then they're there, and you have a 1 in 3 chance of getting it right. So in the previous problem, I asked about the 50%. In this one, by eliminating 2 answers, you have a 50% chance of getting it right. If you get every problem to a 50% chance of getting it right, then you pass the Regents. This one, we got it to a 33% chance at least of getting it right. I'm sorry. So yeah, we eliminated 1 wrong answer, so we got a 1 in 3 chance of getting it right. Depending on your estimation skills, you might have gotten it to a 1 in 2 chance of getting it right, or even actually just the final right answer. So we're going to use those strategies in future problems to do our best to eliminate wrong answers, okay? So, and to maximize our score. Number 8, in the diagram below, triangle CAR is mapped onto triangle BUS after a sequence of rigid motions. If AR is equal to 3x plus 4, so I'm going to label that. AR is 3x plus 4. RC is equal to 5x minus 10. CA is 2x plus 6. And SB is 4x minus 4. Okay? What is the length of SB? Okay? So notice that I labeled the lengths. Do you know how many regions I see where the lengths aren't even labeled? And then the answer just is guessed at? How are you going to do this problem? How are you going to do this problem if you don't show the work? I don't think you can. So try to see if you can create an equation. Here's a hint. You actually need this information. I didn't give you how to use this information. I'm gonna let you work on it for a minute and see what you could do based on that. Okay. 50 seconds. There is a definition of congruence that has to do with rigid motions. 25 seconds. If you assume drawn to scale, then you might be able to guess at what might be a correct equation. But if you use the words in the problem, you might be able to just generate a definitely correct equation. And that is our minute. Okay, so I didn't say how to use that top line. In the diagram below, triangle CAR is mapped onto BUS after a sequence of rigid motions. That implies that triangle CAR is congruent to triangle BUS. In fact, that's one of the definitions of congruence. Believe it or not, when I was in high school, we did not learn, at least in my school, and I don't remember it being tested either, we did not learn that two triangles are congruent if you could map one onto the other via a sequence of rigid motions. And that was a frustration for me because I knew that, and I kept saying that to the teacher. They're like, but how do you know? Literally, side, 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 sure. But there's 1,000 other reasons. So what that means is that CAR is congruent to BUS, and this is important to know. The vertices have to be written in order: the first vertex, the second vertex, and the third vertex, in that order. So CA corresponds to BU. AR corresponds to US. Second and third corresponds to US, second and third. And CR, first and third, corresponds to BS, first and third. Now I see two lines that are congruent to each other with a measure that's given. And there is where your correct equation comes from. We got that 5x minus 10 is equal to, which is CR, is equal to BS, because they correspond to each other. Two congruent sides correspond to each other, 4x minus 4. And now we have an algebraic equation that we could solve. Let's subtract 4x, subtract 4x. I got x minus 10 equals negative 4. Add 10, and we got that x is equal to 6. And I'll tell you this, in algebra, often what we care about is x, but that's not what they ask about always. And look at 6 waiting for us right there. Unfortunately, students get this wrong by getting x equals 6, getting excited and stopping. They did not ask. You have to always, once you get the variable, you have to check what they asked for. They asked for the length of SB. And at this point, I'll say this. A lot of students aren't fans of checking their answers. The reason I recommend estimations, as I've been making them along the way, estimations, is that your estimation actually is faster than most checks, but it serves as a pre-check too. So based on the value of x equals 6, we could put that number in to SB, and we get that 6 times 4 minus 4 is equal to, according to our calculators, 20. Now, about checking our answer, it turns out that a lot of geometry problems, compared to algebra and algebra 2 problems, a lot of geometry problems may actually be longer to get to the final answer, but faster to check. And look at this. So in other words, we do a bunch of work to get the answer, but checking the geometry is faster. We just have to check that CR and SB are the same size. 5 times 6 minus 10, according to the calculator, is also equal to 20. So it's guaranteed that our answer is correct. Guaranteed. Now, when you finish the Regents and you want to go back and check your answers, you know for a fact that this answer is correct, which is phenomenal. Phenomenal. Numero 9, number 9, and I highly suggest using scale for this one too. In the diagram below, triangle GHJ is dilated by a scale factor of 1/2, centered at point B, to map onto triangle CDF. Dilations, think about what you know about dilations. And it does look like that's true. This triangle looks like it's dilated to be this triangle, and here's point B. And now if the measure of angle DFC is 40 degrees, DFC, 40 degrees, what is the measure of angle HJG? Okay. I put a dash there just temporarily. Let's take that minute. This is a very, very doable problem from scale, from estimation, from things that you know to be true about geometry. A lot of students get this wrong just by not even labeling the figure. And I just did. Now, by labeling the figure, it's almost like the answer has to be what it is. 39 seconds. Think about the things that you know. If you don't remember anything at all, think about scale. See if you can confirm that it's drawn to scale. If you can't confirm that it's drawn to scale, tell me if you think it's drawn to scale. And if you think it is drawn to scale, use that to choose an answer. That's our minute. Okay, scale. So the top triangle is dilated by a factor of 1/2 to get the bottom triangle. Here's the thing about dilations. Dilations preserve angles. Dilations, in fact, preserve parallelism. Because they preserve parallelism, meaning that if a line is dilated, the dilated line is parallel to the original line. Because dilations preserve parallelism and preserve angles, because they preserve parallelism, they preserve angles. And that includes dilations by a negative factor, because, again, for the same reason, the original line and the dilated line are parallel, and if you use two sets of parallel lines to make angles, you create congruent angles. So as a result, angle F is congruent to angle J. So I'm going to put a dash there, because a single arc with a single dash, same size. That's it. Now let's talk about scale, because I didn't mention scale. Angle H and D look like they're the same size, and that should be true for dilation. Angle G and angle C look the same size, and angle F and angle J look the same size. And a dilation preserves similarity, so triangle GHJ is similar to triangle CDF. Here's the third vertex, here's the third vertex, and that means that angle F corresponds to angle J. So angle DFC is 40, that means angle GHJ or HJG is also 40. But just by scale, though, since scale is preserved, a 20-degree angle. Here's a 90-degree angle. Here's what a 20-degree angle looks like, smaller than the 30-degree angle. Here's what a 40-degree angle looks like. Here's what a 45-degree angle looks like. So here's a 40-degree angle. Here's another 90-degree angle. Here's a 45-degree, well, here's a 60-degree angle, bigger than 45. And now an 80-degree angle. I mean, that's almost a 90-degree angle. Sometimes visually, I could tell an 80-degree angle, but people start having trouble telling between a 80-degree angle and a 90-degree angle at that point. And as Laura said, can you use ratios on this one? I believe you're talking about this one, Laura. Yes, you can use ratios to prove that the triangles are similar. And because the triangles are similar, then the angles must be congruent. Okay, numero 10, number 10. Now, this one doesn't have a diagram, but it doesn't hurt to do a quick rough diagram for yourself. Directed line segment AJ has endpoints whose coordinates are A, 5, 7, and J, negative 10, negative 8. Point E is on AJ such that the ratio of AE to EJ is 2 to 3. What are the coordinates of point E? So I'm going to give you guys a minute. Do the best that you can. If you don't know how to do it algebraically, we'll do it algebraically. I promised that we would do every single problem algebraically. I'm doing the full math, but I also want to do some process of elimination stuff to get you the maximum grade possible. I strongly suspect that if you just do a good quality rough graph of this, that you can get the answer. A good quality rough graph, I think, is all you need to get this answer correct. 30 more seconds. Okay, so I said a good quality rough graph, but let's actually talk about the back of the Regents. I'm going to paste this right here. Okay, and the back of the Regents. There's a piece of the Regents after the formula sheet, right? So you got the problems, and then you got scrap. It's before the formula sheets where you got scrap graph paper. Don't forget that you have scrap graph paper. It's there for you. Might as well use it. I'm gonna make a rough graph. But I made a rough graph on the side. But the truth is, might as well make a rough graph on the actual graph paper. So we have A 5, 7, and we have J 10, negative 10, negative 8. So I'm going to make my rough graph. Now, you can make this with your straight edge, which I, as you already know, highly recommend. Okay. Straighten that one too. Thank you. Thank you, software. It used to never do that for me, straighten out lines, and clearly sometimes it doesn't. So A is 5, 7. Here's 5. So now, when I say rough, let's talk about rough graphs and neat graphs. A rough graph has some of the details that are relevant in an accurate way. And then some of the details are just kind of missing. Okay? But here's the thing about graphs for at least the part 2s, 3s, and 4s. Neatness does count because the graph locations have meaning. Like, I know a lot of students move points to other places where they don't belong to make them more visible or something. But the thing is that's not how graph papers work. Notice that this dash is on the line. A lot of students like move it to see it better, but that's illegal. So negative 10, negative 8 is right here. Now let's see if it'll actually straighten this line. Yes, love it. It used to not do that for me. So this is the line. And now what I'm going to do is I'm going to grab all of these points on the paper. 1, negative 1 is down here. This is choice 1. It's choice 1. Choice 2, negative 5, negative 3 is right there. Choice 3, negative 4, negative 2 is right there. Choice 4, negative 1, 1 is right there. So for right now already, we could eliminate choice 1. Notice it took me a certain amount of time to create this graph. Now you might be asking, is it worth my time to do that? My answer to you is this. If you reduce the amount of time to do the problem, but don't do the work to get it 100% right, then what is the value of your time? Vice versa, if you spend a little bit of extra time, but then you get the problem right, what is the value of your time? I have a rough statement to that. I think it actually is a good rough statement. If you take the amount of time that you spent working on the problem divided by the probability that you got it right, that's a good estimate of your time. So like if you take 3 minutes on this problem, remember the Regents is 180 minutes. So if you take 3 minutes on this problem, but you got it 100% right, then you take 3 divided by 1.00 is 3 minutes. But if you spend 2 minutes on the problem, but you got like a 25% chance of getting it right, well, 2 divided by 25%, 2 divided by 0.25 is 8. That's how much time you spent, which is worse. You spent more time, at least in terms of value, on this question. It's a rough statement. But it's a good convincing one to convince you that it actually is worth your time to do the graph. So now they say that AE to EJ is equal to 2 to 3. So E is closer to, well, AE to EJ is 2 to 3, so AE is shorter. So E is closer to A than to J. Okay? Which means that the answer has to be, and it has to be on the line. Because they did say it's a directed line segment, and point E is on AJ. On the line segment. So that leaves, the only one that's closer to A on the line segment is choice 4. So it has to be choice 4. Why am I not circling choice 4 and saying move on? Because a lot of times students just move on after we go to do the problem. But if this one's not looking good, this one's not looking good because it's too far away, and choice 1 is definitely incorrect. But how do you actually do the problem algebraically? And the reason I'm doing it algebraically is because, and my fair warning to you, you should definitely stick around to watch me do this problem algebraically. The reason is that on part 2, 3, and 4, this problem could appear exactly like this, and then you actually have to do the algebra or do the work on the graph paper, but you have to know how to do the work on the graph paper. So if this is the point x comma y, now we already kind of know the answer is going to be negative 1, 1. So by visually speaking, now this algebra could serve as the check, or vice versa. The algebra could serve as the work, and the graph serves as the check. So if the point is a generic xy, and this is the point 5, 7, and this is the point negative 10, negative 8, then I could actually get the distances horizontally and the distances vertically. I know that from A to E, so 5 minus x in the x direction, divided by from xy to negative 10, negative 8, so x minus negative 10, that's equal to 2 to 3. And now I do some cross multiplication. And I got 3 parentheses 5 minus x is equal to, you could do some simplification because we are doing the algebra fully. Parentheses x minus negative 10 is that to plus 10. Distributive property. We got 15 minus 3x equals 2x plus 20 plus 3x plus 3x. We get that 5x, so 15 equals 5x plus 20. Subtract 20, subtract 20. Get that 5x equals negative 5. Divide by 5, divide by 5. We get that x is equal to negative 1. And that confirms that the x coordinate has to be negative 1. The only one remaining with that x coordinate is that. Now, if you wanted to get the y coordinate, because it might be a part 2, 3, 4 problem on the Regents this June, or a future Regents, I'll give you the equation in the y direction also. The y direction, the ratio also has to be at a ratio of 2 to 3. So we get the a, 2xy, so 7 minus y divided by from y to negative 8, y minus parentheses negative 8, that's equal to 2 over 3. And this is the equation that you solve to get the y coordinate. Now that we know the answer is actually 1, actually for y, worth noting, because choice 4 is the only one that has an x coordinate of negative 1. Now that we know the answer has to be y equals 1, because it's a multiple choice question, we could use that as an advantage. We just plug in y equals negative 1 and make sure we get the right answer. And we get on the left side, we get 6 over 12, 6 over 9, 6 over 9, and 6 over 9 is equal to 2 over 3, according to the calculator. Okay? Number 11. Now, this is a problem, by the way, that a lot of teachers might fight with me, like Kumite style, because is it drawn to scale or not? Is it drawn to scale or not? And I think it's a valid fight. This is the one problem that I think it's a valid fight, whether this question is drawn to scale or not. And I'll talk about why, but I depending on the way your brain works, you might see it as drawn to scale, and depending on how your brain works, you might see it as not drawn to scale. And I'll tell you why both are right. This is one of the rare cases where both sides actually have a leg to stand on. So fighting Kumite style on this one to ask whether it's drawn to scale or not is not really actually worth it. Because, okay, I'll talk about why after. A tipping platform, numero 11, number 11, a tipping platform is a ramp used to unload trucks as shown in the diagram below. Cool. So that stuff's just going to fall off the truck. All right, cool. So I'm actually visually seeing that because they actually show me the picture. The truck is on a 75-foot long ramp. Okay. The ramp is, and I might as well label the ramp right away because I'm doing this because I'm telling you, you should do this, 75. The ramp is tipped at an angle of 30 degrees. And this is where a lot of teachers might fight me. I'm going to switch colors because for my colorblind folk, by the way, 10% of males are colorblind. Did you know that? And I am among you. I am colorblind as well, which the reason I switched from red to blue is that for me, being colorblind, I couldn't see the red. Although it might be super bright to you, to many of you. Females, only about 1% of you are red-green colorblind. So, what is the height of the upper end of the ramp to the nearest tenth of a foot? So we are looking for the upper end of the ramp, and they actually give us a letter for it, x. To the nearest tenth of a foot, 68.7. 65.0, 43.3, 37.5. Let's get that minute. And decide whether you think it's drawn to scale or not. I wonder how you feel about it. Hi, Sean. Thank you. I see you. Thank you. Another 40 seconds. 40 seconds, and then we'll get to it. Think about scale again. There's a lot that we could say about scale. They should have a picture of a truck on the ramp. I mean, maybe something useful there. 20 seconds. And if you're not used to showing work, but now you have been convinced by my rants to show work, there's probably some trig that could be done here. All right, there's your minute. There's your minute. So why do teachers fight Kumite style on this, asking whether it's drawn to scale or not? So the reason is that this triangle is sorry, I just clicked on something and now it's making me log into something. The triangle is if you delete the background of it, then you have a triangle that doesn't necessarily look to scale because of the perspective. Because of the perspective, though, the fact that you're not looking at the truck perfectly head on, but you're looking at it at an angle, the scale changes just because you're looking at it at an angle. If the truck picture weren't there, I would say it's not drawn to scale. But because the truck picture is there, I would say that it is drawn to scale. So some of you may be looking at this and saying, Juan, of course it's definitely drawn to scale. You could see that it's drawn to scale. And other people are like, no, that it's definitely not drawn to scale because your brain removes the truck and only looks at the triangle. So you're kind of both right. If the truck weren't there, it wouldn't be drawn to scale. But because the truck is there, it is drawn to scale. Either way, though, drawn to scale or not, this angle is 30 degrees. If you erase the truck, this angle looks like it's slightly larger than 30 degrees. But either way, the x would only be shorter if you decrease the size of the angle below 30 degrees, which means that x can't be anywhere near 75. That eliminates, for sure, using scale, using correct scale, 68 and 65, leaving only choice 3 and choice 4. Now, using correct scale, using that the fact that the truck is there, actually now x becomes a lot shorter than even that, but still, I can't, personally, visually, I can't differentiate between a 43.3 and a 37.5. Now, the 30, 60, 90 triangle is a very important triangle to know. We talked about it before, right? This one's not drawn to scale. I want to change my triangle. Okay. This one, so the 30, 60, 90 triangle, we have x radical 3, and 2x. The side opposite of the 30-degree angle is half the length of the hypotenuse. Half of 75 is 37.5. That's just knowing the 30, 60, 90 triangle. If you don't remember the 30, 60, 90 triangle, then what you got to do is sine of 30. This is the opposite leg to the 30-degree angle. Okay, so sine of 30, and this is of course the hypotenuse. Sine of 30 is equal to the opposite leg over the hypotenuse. So we got sine of 30 is equal to x, because they give us the letter x, divided by the hypotenuse, 75. Now, I know a lot of students are fans of cross multiplying. You can put this over 1 and then cross multiply. Why I used to not be a fan of it, because you could just multiply by 75 in this case. But I would rather you cross multiply, to be honest. Put it over 1 and cross multiply. I gave up on that one. I think it's right because it fixes cognitive dissonance issues. So according to your calculator, you put this in the calculator. 75 sine 30. And it's exactly 37.5. It's exactly 37.5. They said to the nearest tenth of a foot, but it's exactly 37.5. That's how to do this problem. All right, numero dos, number 12. In the diagram below of right triangle MET, altitude ES is drawn to hypotenuse MT. If ME equals 6 and SM equals 4, what is MT? So I'm not going to label the triangle now because I want you to simulate that. So I want you to draw the triangle and label it and then use that to get the answer. I'm going to give you your minute. Okay. In the meantime, I'm going to log into this chat. Oops. "28 seconds. "15 seconds. All right. So it looks like I no longer have visuals of the chat. So I'm gonna ask my moderator to add things as she's been doing. Say everyone say hi, Jelly. If you're here, say hi, Jelly. Thank you, Jelly, for your moderation. Um, but I no longer have access to the chat, so just put out basically anything that's very relevant to it. Uh, so, and by the way, the question of how do I support this channel? Literally, just subscribe. That's the only thing that I need from you. I don't require payment. I don't require donations. I'm not asking for them. All I would love from you is to subscribe. And of course, if you feel like this is helping, and if you're a parent or feel like my tutoring would be something useful for you, please do feel free to contact me at JuanTutors.com. And again, thank you, Jelly, for moderating. I really appreciate your effort. In the diagram below of triangle MET, again, altitude ES is drawn to hypotenuse MT. If ME is 6 and SM is 4, what is MT? So if I'm doing this problem, you know I will be labeling. So they said that ME is 6. They said that SM is 4. And they asked for MT. Okay, there's one silly question here. What MT is. 4, this one's silly. So if you got 4, I'm sorry that you got it, but this actually is a hint that maybe you didn't do enough labeling for the problem. They gave you MS or SM, and they want MT. MT contains SM. MT has to be longer than SM. So it has to be longer than 4, guaranteed. Now let's talk about scale. The only things that we're told here, right triangle MET. MET looks like a right angle, perfect. Altitude ES is drawn to hypotenuse MT. MT is the hypotenuse. ES is looks perpendicular to MT. Great, that's drawn to scale. ME is 6, nothing violating that yet. SM is 4. Now 3 is half of 6. MS looks more than, or SM looks more than half of ME, but it doesn't look as long as ME. So this is drawn to scale, and there's nothing else that could be violated. So this is drawn to scale, DTS, which means that, now I will say this, there is one little piece. This is where I'm gonna just, it is drawn to scale, and I want to be clear about it. It is drawn to scale. But I can confirm that using software. It is really close to a point where it might just barely not be drawn to scale. So it really is drawn to scale. But the reason I'm mentioning that is that like ST and MS are so close to each other in length that I'm not necessarily willing to commit to it being perfectly drawn to scale. I am willing to eliminate choice 3 of 5 because it's really very close to drawn to scale. So ST has to be close to MS. But I'm just not personally willing to commit to eliminating 8 or 9. There is a reason why one of these I would eliminate. But if ST is 4, choice 2 is correct. And if ST is 5, choice 1 is correct. There is a reason, again, why I can eliminate one of them. But in terms of scale, it's just a little bit rough. Rough to commit to that. Now there's a theorem that we could talk about. There's what I call the cheat code for right triangles with an altitude drop from the right angle. So you do need to know this, that all 3 triangles here are similar. What 3 triangles? You might be saying, what 3 triangles? Because there's a triangle on the left, there's a triangle on the right, but there's also a triangle on the outside. And so the cheat code is this: you do the vertices for the triangle on the left, you do the vertices for the triangle on the right, and you do the vertices for the outside triangle in that order, in the correct order, the corresponding order. Okay? So left, right side, and outside. So, and I start with the right angle vertices. The left side triangle, the right angle is at S. The right side triangle, the right angle is at S. And then the outside triangle, the right angle is at E. Now, start at the left side triangle, I know that, well, M on this angle M on the left side triangle corresponds to which angle on the right side triangle. I might not know this as a student, which angle it corresponds to on the right side triangle, especially since these angles look so close to 45 degrees. I might not be willing to commit, but on the outside triangle, angle M is an angle on the outside triangle, so M corresponds to M on the outside triangle. And then on the right side, on this angle T, on the right side triangle, T corresponds to T on the outside triangle because T is literally an angle of the outside triangle. So now what about the third vertex? Well, the triangle on the left is triangle MSE. The only one that's missing is vertex E on the left side triangle. And the triangle on the right side is STE. The only vertex that's missing is vertex E. Here's our cheat code. On all three triangles, the correspondence is this: S to S to E, M to E to M in that order, and E to T in that order. So I can make a ratio now of sides. Now I notice that MS and ME are sides of the left side triangle, so I'm definitely going to use this one. Okay, now ME is also a side of the outside triangle, and MT is a side of the outside triangle. So I'm going to use the outside triangle as well. And I'm going to do this with the correct vertices using the cheat code. So what's the cheat code say? On the left side triangle, MS, second, that's 1, 2, 3 in that order. MS, so MS, that's vertex 2 and vertex 1. On the outside triangle, vertex 2, vertex 1, ME, 2 and 1. That's equal to, on the outside triangle, on the left side triangle rather, ME, so left on top and outside on bottom. And then on the left side triangle, ME, and according to my cheat code, that's the second and the third vertex. Oops. The second and the third vertex in that order. So now I have to give the second and the third vertex in that order on the outside triangle, MT. And I have a ratio of things I could solve for. MS, 4, over ME, 6, equals, on the right side, ME is still 6, divided by MT, which is not known. But I'm looking for MT. And I have one variable, might as well use it. Okay, now I do my lovely cross multiplication. 6 times 6 is equal to 4 MT. Divide by 4, divide by 4. We get that MT. And we go to our calculator. 6 times 6 is 36 divided by 4. I got one installed in here. That's why I did it so quickly. MT is equal to 36 divided by 4, which is equal to 9. Now, why is it that I actually secretly knew that the answer was going to be 9 and not 8? As I said, using scale, I wasn't willing to quite commit to 8 not being the answer, since ST looks so close to MS that just changing the angles just ever so slightly changes ST to be shorter or longer than MS. The reason though I knew that it was not going to be 8 is because that would imply that ST would be exactly MS, and 4 and 6 there isn't that doesn't make a 45 45 90 triangle. So I knew that it wasn't going to be exactly 4 plus 4. All right. As I said, and this is going to be very short, before number 13, the only real self-promotion in this video for students, moms, and dads. If you're interested in tutoring, go to JuanTutors.com. And if you are a teacher, we are hiring top quality tutors. So we do have a lot of tutors with us, mostly math tutors, but we have English tutors, we have science tutors, we have history tutors, we have art. We have a phenomenal art tutor. So go to JuanTutors.com if you're interested in getting tutoring. And I really do appreciate that support. Before number 13, there's also a question about, might as well leave this up while I'm talking about this other thing. There's always a question about what you should bring in terms of snacks to the Regents. So I'm going to put the word snacks here. So First off, this question, coffee. You see me drinking coffee because it helps because I'm coughing, because I'm talking a lot. You're not talking during the Regents. You don't need coffee to prevent coughing. Why do you need coffee though? So here's the thing. I'm not going to say I recommend coffee, nor am I going to say I recommend not drinking coffee, because. But what I am going to say is this: like, you should not be drinking a whole cup of coffee or two if you're not a coffee drinker. Coffee, despite it being legal, it is a drug. And I'm not being one of those adults like coffee is a drug. No, coffee's a drug. Coffee's a drug. And if you go to drink coffee when you're not a coffee drinker, what ends up happening, you end up using up all your reserves of energy, and you end up getting really hungry because now your body is craving sugar. One of the things that caffeine does is it actually allows your body to use caffeine more, use uh, sugar more efficiently. That's one of the things that it does. But it also causes you to crave sugar, and because you're in the middle of a test, you might have a craving for sugar that you can't satisfy, and so uh, you get jittery at a bad time, which is right around near the end of the test when you're actually trying to have more energy. So coffee is not something I recommend unless you're already, with parents' permission, already an avid coffee drinker. That said, um, decaf coffee has caffeine in it. And it actually, a lot of adults say, why would you ever drink decaf? Well, a lot of adults say it because they drink coffee, uh, regular caffeinated coffee. I actually switched to decaf in the morning because I became so desensitized to coffee that coffee stopped even helping me. And I started getting to like a 4 or 5 cup a day kind of situation. That was not good. But switching to decaf really helped because it turns out that in the morning, I actually only need a little bit of caffeine. And again, decaf coffee has caffeine in it, and it has just about the right amount for someone who's just not an avid coffee drinker. And if you're not an avid coffee drinker, you might find that the bitterness of it might actually prevent you from over drinking too much coffee. So I do recommend for a non-coffee drinkers to avoid regular coffee like the plague. And if you really want coffee, go for decaf. I also would say if you are a milk drinker and you know you're not at all even close to lactose intolerant, maybe you can use milk. But I would go for a lactose free milk, or in fact, uh, throw a lactate pill in there and shake it up to make sure it dissolves, or crunch it up before you throw it in there, and shake it up every time you go to drink before you drink. And don't spill any on your test. Now, in terms of physical snacks, this is I'm not sponsored by Pure Protein, but hey, Pure Protein, if you like the fact that I just mentioned your product in this video, go ahead and sponsor me. But I like these. They have 20 grams of protein, so they're nice and filling, and they stave off hunger. And that's really actually what you need during a test. You don't actually need a lot of carbs. They do have 18 grams of sugar in them. So I'm not promoting these for health reasons. I'm promoting these for test taking. They have a little bit of fat, 18 grams of protein and 18 grams of carbs and 20 grams of protein. So it does give you a little bit of that energy boost without causing any crazy jitters. So I do recommend that. And I do have 3 here with me for myself during this video. They're actually here for me for myself during this video. And the last one, I'm asthmatic, so I always have my Weezer squeezer. Do bring your Weezer squeezer with you for the test. Okay, so in case you need it, so don't forget that. Okay, now I'm going to go to number 13. Número 13, number 13, and this I see this diagram with a lot of scale usage available to it. So number 13, número 13, in the diagram below of square CASH, diagonals AH and CS intersect at Z. Which statement is true? Now I'm going to take a quick look at the diagram before I go on. They said square, which has an enormous amount of structure and congruence. AH and CS intersect at Z. Which statement is true? The measure of angle ACZ greater than the measure of angle ZCH? Go label. Measure of angle ACZ is less than the measure of angle ASZ, or the measure of angle AZC is equal to the measure of angle SHC, or the measure of angle AZC is equal to the measure of angle ZC. So I would take your time and just label and do what you can. Remember, it's a square, okay? It's a square. Label what you can. I'll give you your minute. Label what you can. That's my piece of advice. I mean, if you just label for this problem, you're going to go so far with it that, I mean, you might just get it right just by labeling. Don't forget what you know. It's a square. You know a lot of stuff about squares. You know a lot of stuff about squares. Please do use that stuff about squares, okay? 30 seconds. Twenty seconds. Start using scale. It definitely looks like a square. There we go. Okay, so in this diagram, it's a square. CASH. Does it look like a square? OMG, does it look like a square? CASH. All right. So do all those look like they're congruent? Absolutely. Do all the angles on the square look like they're actually right angles? Absolutely, positively. And diagonals AH and CS intersect at Z. Are they diagonals? Do they connect opposite vertices? Yes. Do they intersect at Z? Absolutely. All straight lines look like straight lines. And by the way, one of the few assumptions that you're allowed to make in geometry is that objects that look straight are straight. And that's just to be able to have the conversations that we're having. So, yeah. But so now, which statement is true? I think that choice one and choice two are the harder ones to verify. So I'm actually going to hop over to choice three and choice four. I'm purposely going to hop over to choice four because, well, because I happen to know that it's wrong. But I know that it's wrong just based on measurements and labeling. Okay, so just do know that. I didn't guess. I didn't visually say it. I looked at it. So AZC. This is angle AZC. Okay, and here's angle ZCH. This angle, does this angle, which is a 45-degree angle, look like that angle in the middle? Now, here's one of the things that it helps you to know is that the diagonals are perpendicular, okay? So a square implies that it's a rhombus, implies that the diagonals are perpendicular. In fact, they're perpendicular bisectors. They're perpendicular bisectors, which are also angle bisectors in a rhombus. But in this case, we only care about the fact that they're perpendicular. So does a 45-degree angle equal a 90-degree angle? No. Choice four. Okay. Let's look at choice one and choice two. Well, actually, yeah, choice one and choice two. Angle ACZ, angle ACZ, this angle, which is 45 degrees, is that greater than the measure of angle ZCH, also 45 degrees. Now, if I didn't know that they were 45 degrees, they look so similar. Turn my head, they really very much look similar. I couldn't say that these are one's bigger than the other. In fact, I would actually argue the following, and I could prove that it's not, that they're actually congruent. If you reflect the angle over a horizontal line through the center, then you get the figure rotated, reflected onto itself. Then if you reflect it over 90 degrees, you get the figure rotated, reflected onto itself, which implies that then if you also rotate it by 90 degrees, you get the figure reflected onto itself, which means that all of these angles have to actually be congruent to each other. And if they're congruent to each other, congruent adjacent angles making a 45-degree angle have to measure 45 degrees. So this one's actually definitely wrong. 45 degrees equals 45 degrees. And again, the measure of angle ACZ, 45 degrees, is less than the measure of angle ASZ. This is again 45 degrees. So these are actually congruent to each other. So this is not right. Now angle AZC, that's a right angle, is equal to the measure of angle SHC. That's also a right angle because this thing is a square. So 90 degrees equals 90 degrees. And that's how to do this problem. Okay. Hopefully you got this one right. Hopefully you used structure to get some information out of it. Like if you're resisting showing work, at this point, I'm hoping I've convinced you. Okay? Número 14, number 14. In the diagram below of circle O, secants CFD and CHE are drawn from exterior point C. If the measure of angle DE is 136 and the measure of angle C is 44 degrees, then FH is, the measure of angle FH is, arc FH is 46, 48, 68, 6, or 68. That's a big range from 46 all the way up to 88. That's almost double. So you might be able to visually estimate and use scale to determine if one of these answers maybe doesn't make sense. So I'll give you that minute. Using scale again, my advice, I'm actually jumping into my first snack. Chewy chocolate chip. Pure protein, you should totally sponsor me. Chewy chocolate chip, chocolate peanut butter, or chocolate deluxe. Let's go for chocolate peanut butter. 40 seconds. Decided I don't necessarily recommend recording while eating these because they're very chewy. But they're great when you don't have to talk, which is great for a Regents. It'll keep your mouth shut. So in the diagram below circle O, secant CFD looks like a secant CHE drawn from external point C. That looks true. DE, the measure of our DE is 136 degrees. 136 degrees. Let's decide if this is maybe drawn to scale. Draw a right angle there, draw there, draw that. So this would be, wow, I mean, this looks like 136 is just 1 degree bigger than 135. And 1 degree, believe it or not, is big enough that the pixel interference pattern is visible. In other words, 1 degree has weird pixel effects, and you can't even see pixels on your screen unless you like get really close to the computer. So this looks exactly right. So 136 looks drawn to scale. DTS, drawn to scale. And then the measure of angle C is 44 degrees. If I draw a perpendicular line to E by turning my head, this looks like a 45, 45, and 45, and 44 again, 1 degree less than 45. This is drawn to scale. Okay. I'm gonna erase this dotted line. That C is drawn to scale, and that's the only thing that could be violated. So this whole thing is drawn to scale. Drawn to scale. We've confirmed that it's drawn to scale. So then they ask for the measure of arc FH. So at this point, I'm gonna continue to H, and this almost looks like a straight line, but it's not meant to. That almost looks like a right angle, but it's not meant to. So FH looks so close to 45 degrees that I'm not willing to abandon 46 or 48. And we've confirmed that it's drawn to scale. So we're using scale correctly. Now, you might be not willing to abandon 68, but you might think that it's wrong. Visually speaking, if it's so close to drawn to scale, maybe you're not willing to abandon 68, but you suspect that it's wrong. But 88 is so close to 90 degrees. We're talking about 90 degrees compared to like 88 degrees. I can't even draw a 2 degree angle, nor can you. And if I try to use the software to draw a 88 degree angle, I'm not sure if it'll let me. It doesn't even let me. So, because the 2 degree angle is so small that it's just silly. So it's definitely not 88. How to go about this problem though? the theorem to know is that the angle outside is equal to half the difference of the two arc measures. So the measure of angle C is equal to half the difference of the two arcs that it subtends, DE, minus the measure of FH. So if we plug in some numbers here, we got 44 is equal to a half of the measure of DE, is 136, minus the measure of FH. Now, the fact that we don't have the measure of FH is okay because that's what we seek. We seek FH. We can also, at this point, if you don't know how to solve the equation algebraically, you can actually now plug in to the calculator 44. And I've solved a few distributive property problems already. So I'm going to do this one on the calculator. Although I did do this algebraically. And I'm going to do it algebraically on paper because I promised that I would do every problem algebraically also. So on the left side, I just have 44. That's entered. Done. And on the right side, I have a half times parentheses 136. Now, I might guess that it's choice 1 or choice 2. I'm going to guess choice 1, 46. And do I get 44? No, I get 45. All right, so I guess now 48, and I get 44, which is exactly the measure of angles, what the equation says. So the answer is choice 2, 48, but we're just going to confirm using the algebra because I promised that 44 equals half of 136 is 136 minus 1/2 the measure of FH. So 1/2 of 136, 120 divided by 2 is 60. And then 816 divided by 2 is 8. Minus 1/2 FH. Okay, equals 44. Subtract 68. Subtract 68. And I get that negative 1/2 FH is equal to, so 68 minus 44 with a negative sign is 24. And there's my 48 peeking out if I multiply by negative 2 times negative 2 times negative 2. And I get that FH, the measure of FH, is equal to positive 48, which confirms that that's the right answer. All right. Groovy. As promised, so we're going to use scale on this one too, and every single problem that we can use scale on. So, numero 15, number 15. A right circular cylinder has a diameter of 8 inches and a height of 12 inches. Which two-dimensional figure shows a cross-section that is perpendicular to the base and passes through the center of the base? I go ahead and try this problem, but I'm going to give you the minute. Think about drawing a diagram and seeing if you get this question right. Draw a diagram for yourself. I don't know if you can get this question without actually drawing a diagram. I will say this problem, this is usually what the problem looks like on a test that's submitted, because the student doesn't bother drawing a diagram, they don't bother getting the question right. A lot of those, like replacing the radius with a diameter or replacing a diameter with a radius, completely fixed by just drawing a diagram. Okay? Five seconds. Not surprisingly, talks about a right circular cylinder with a diameter of 8 inches. Almost always on this test, they think they're being clever and tricking you by giving you the diameter and seeing if you remember to use the diameter versus the radius. Or they give you the radius when you actually need the diameter, trying to trick you to see if you get the right length. It's almost always, but not always the case, that you need both. All right? One or the other. But then they also try to trick you sometimes and give you the length that you need to see if you trick yourself into getting the wrong length. And I think that's kind of what happens in this problem. So a right circular cylinder has a diameter of 8 inches and a height of 12 inches. So I try my best to draw it to scale, so I draw a height that's taller. Okay. And then which two-dimensional figure shows a cross section that is perpendicular to the base and passes through the center of the base? So now, how do I visually interpret this problem? All that cross sections are what happens when you take a shape and cut it in pieces. So like if you imagine, if you're Latino, you know what a salami indubeca looks like. Imagine getting a salami, slicing it, and then slicing it vertically. Or if you are a fan of, let's say, for example, cranberry preserve in your turkey during Thanksgiving, it comes out of the can in a perfectly solid, like right circular cylinder that you might then cut vertically. And that's actually what's happening. So we cut this vertically, and what we end up getting, we cut down the diameter, and we cut vertically, and we cut horizontally down the diameter, and then we cut vertically. So we end up getting a rectangle. Okay. And if you notice, in this case, the diameter is 8. So the width of the rectangle is 8. And then the height of the rectangle is the entire height of the cylinder, which is 12, which is looking good. So this answer is looking good. This answer is looking very bad because they used the radius. This is the radius, not the diameter. So they used the wrong length. You're missing half the cylinder. Now, where does choice 1 and choice 2 come from? First off, choice 2, they said that the diameter is equal to 8, and this is not the radius. This circle has a radius of 16, not 8. No, I'm sorry, yeah, this circle has a radius of 8 and a diameter of 16, where they said the diameter is equal to 8, and the height is 12. So where does choice 1 come from, though? A lot of students do get choice 1 thinking it's correct. So the thing is that here, they said perpendicular to the base. So that means perpendicular to the bottom. The bottom is, if the bottom is sitting flat, you're going perpendicular to the base, you're going up and down. If you go parallel to the base, you do get a cross section that looks like choice 1. If you go parallel to the base, think of that salami indubeca. You got a salami, cut it this way, you get a circular cross section when you cut it that way. Okay, or that cranberry preserve, you got it coming from a can, which is a right circular cylinder, cut it this way, and you got a circle on top. So that's where that answer comes from. But it's not that one because they did not say parallel to the plane. To the base, they said perpendicular to the base. Okay. Número 16, number 16. On the set of axes below, AB is drawn and passes through A, negative 2, 6. And that is that point right there. And B, 4, 0. And they said if CD is the image of AB after a dilation with a scale factor of 1/2 centered at the origin, which equation represents CD? Okay, so I'm going to draw that point here. Put that O for origin. And I'm going to give you that minute. But think about what you know about dilations. Don't guess at this one. Think about what you know about dilations. Well, I mean, if you need to guess at this one, guess at this one. But use things that you know to be true. Okay? Use things that you know to be true. Don't guess at how the dilation should have an effect on this thing. Actually think geometrically what the dilated line looks like. If you think algebraically, 50% of you will get the question wrong, unfortunately. But if you think geometrically, 50% of you will get it right. Still 50%. Got 8 seconds left, 7 seconds. Okay, dismiss. Thank you, Esperanza. I got a Facebook message. Thank you, Esperanza. Okay, so choice 1, 2, 3, and 4. I mean, I know why people would choose choice 3 and 4 if they just kind of multiply the equation of the line by a half and then do something, they might guess choice 3 or 4. Uh, but if you actually think about what a dilation does geometrically to an object, you might actually get the question right. So I'm going to label a point P here, the y-intercept, because the thing is that A, I could dilate easily by a factor of 1/2. P, I could, the y-intercept, actually I shouldn't call it P, I should call it B, shouldn't I? Little b. Uh, I didn't label it in my work, I just drew the dot. And capital B on the x-intercept, I could actually dilate those pretty easily. And if I do dilate the point -2, 6, that multiplied by a half, centered at the origin, is the point -1, 3. Okay? -1, 3. Let's get that 3 looking like a 3. And then the point B, dilated by a factor of a half, y equals 4 times a half, is dilated to y equals 2. I'm going to call that one B prime. Okay? And then finally, capital B, 4, 0, dilated by a factor of 1/2, is the point 2, 0. So that's B prime. And actually, now I have a line. And suddenly I've learned something new here. That if I dilate a line, as we talked about before, we said that that dilations preserve parallelism. And actually, had I remembered that I had said that earlier in the test, I might have been able to eliminate choice 3 and 4 from the get-go because this is a dilation. But we have the actual graph. And the graph has a y-intercept of 2 and a slope of -1. So the equation is y equals -1x plus 2, also known as y equals -x plus 2. That leaving that choice. How do people get choice 3 and 4? By just multiplying the slope by a half. But that just doesn't work because multiplying the slope by a half changes the slope, and dilations preserve parallelism. So dilations preserve slopes. Okay. Número 17, number 17. All right. And we're cruising. And by the way, I think I mentioned this. Why am I doing this live? And I did mention it, but I don't know if you caught it. The reason I'm doing this live is that I used to spend like 3.5 hours on the video and then maybe like 7 to 12 hours or more editing. If I do this live, I could sacrifice some of my video time in favor of giving you a better video, even if like I did earlier, I may be making an error here and there that I would have edited out, but I fixed the error online. And I also just give you more tips and more advice and also give you time to practice the problem. So that's why I'm doing this live. It's going to end up being a longer video, but it's worth it on the day before because I'm giving you advice to get better score. A lot of these videos end up being like an hour and a half to 2.5 hours, and you think that that's just better, but that means that they're rushing through the problems and not giving you any advice. I don't think that helps. I know that my students tend to do better, and people who watch my videos tend to tell me these are the best videos that they've seen. So, I really do appreciate that. If you feel like this is one of the best videos you've seen, please do say it in the comments, and I'll give you a shout out. But let's go for number 17. In parallelogram ABCD with AC perpendicular to BD, AC is 12, BD is 16. What is the perimeter of parallelogram ABCD? Is it 10, 24, 40, and 56? And I see some answers that I could just slash and burn right away. But I want you to see what you could do to slash and burn some answers. Again, it's a parallelogram. Some perpendicularity is involved. What's the perimeter of ABCD? If you don't draw a diagram, you're going to get it wrong. You might, no, that's not true. If you don't draw a diagram, you might get it wrong. If you do draw a diagram, there's a much bigger chance of getting this question right. Significantly greater chance of getting it right. Let's go for another 40 seconds. My advice again, draw a diagram. Draw a diagram. Pure Protein is not sponsoring me, but like I said, if they do decide to do it, I'll totally do a video trying all their bars and seeing which one I like better. Give me a call. All right. So let's actually jump into it. Parallelogram ABCD with AC parallel perpendicular to BD. And now notice that the hold on, it's gonna pause now. The diagonals of ABCD are AC and BD, and this is where a lot of students get it wrong. Do understand in geometry, they have to name the vertices in order. They have to name the vertices in order. Okay, so parallelogram ABCD. So, oh, I see what's going on. So parallelogram ABCD with AC perpendicular to BD. So there's a piece of structure that is not obvious necessarily to somebody drawing this parallelogram. So I'm going to try this a little bit better. But by the diagonals being perpendicular, there's something that's implied. And what's implied is that this is a rhombus. Now, I tried drawing this scale. This one's not my best drawing, but let's see, A, B, C, D. And this is actually partially almost drawn to scale, but AC is perpendicular to BD. Your diagram does not need to be perfect, but if AC is 12, that means that this is 6 and this is 6, because the diagonals of a parallelogram bisect each other. BD is bisected. I'm going to call this point E, just so we have the ability to talk about it. E is the midpoint of DB, because again, the diagonals bisect each other. So if BD is 12, this is 8, and this is 8. Okay, and you may already see a lot that you could do to solve for the perimeter. But here's my slash and burn. First off, DB is 16. Perimeter of ABCD can't be 10. Where a lot of students get it wrong is that they interpret A, C, and BD as the sides of the parallelogram. But the thing is that A, B, C, D have to be given in order. The names of the vertices of the parallelogram have to be given in order. So AC can't be a side of A, B, C, D because A and C aren't next to each other. And BD can't be a side of A, B, C, D because B and D are not next to each other in the name. So, but the perimeter also can't be 16 because the diagonal is 16. In fact, the perimeter has to be bigger than 16 plus 16, which is 32. So 24 is actually too short. So I'm left with 40 and 56. So there is more that I could say about the size of the perimeter. There's a like I could eliminate 56 if I double 16, I get 32, and if I double the other diagonal, 12 plus 24 is 12 plus 12 is 24. Add those two numbers, 16 plus 16 plus 12 plus 12, that's equal to 56. So 56 is actually too big. So that's not the answer. Okay. So how do I do this problem though? Notice that because the diagonals are perpendicular to each other and they bisect each other, we got 4 right angles, 4 right triangles, and the 4 right triangles are congruent by side angle side. They all have a right angle 90 degrees. They all have a side of length 6, and they have another side of length 8. So by side angle side, all 4 are congruent to each other. So if I get AB, then I get the perimeter. So an AB triangle ABE is a right triangle. The Pythagorean theorem holds. So I'm going to call this hypotenuse C. So I got little c. So I got a squared plus b squared equals c squared. C squared. I got 6 squared plus 8 squared equals c squared. And at this point, you can go to your calculator. 100 equals c squared. Did I do that in my head? I mean, let's just pretend I did, because I did it in my head, but I have a calculator installed in my brain. So I have c is equal to plus or minus, but I reject the negative answer because c is equal to a length. Because c is equal to a length. So I got c equal to positive 10. So I got 10, got 10, got 10, got 10. 10 plus 10 plus 10 plus 10 is 40. So that's how to do number 17. If you do appreciate what I've been doing so far, please do hit like on this video so I can get a good count of how many people are liking this. I do often get like 30,000 views on these Regents videos. So I do appreciate that these videos are helping. Please do hit the like button. The thing that does help me most is the subscribe button. And again, I'm not planning on putting a lot of videos out, but the thing that helps me most is the subscribe button. Before we do number 18, I do want to ask you that if you're live, please do post in the chat what kind of videos you want and what kind of videos you would like me to see make besides the Regents videos. I happen to be one of those people that knows a lot about a lot of things. So I could do videos about math. I could do videos about like physics, chemistry, pop science, other Regents, yes, but pop science, economics, stock trading, whatever it is that you are interested in. I would love to make videos, but I'd love to know what you're interested in as a person of the right age who would be watching these videos. Okay? So, or someone who's a teacher, but you just want to see certain types of videos anyway. I would love to make them for you. Now, again, the chat is not synced to me. I'll see it later. So please do type something, and I'd love to know so I can make videos of that type. But numero 18, number 18. In the diagram below of triangle CAT, the measured angle A is 90, and the altitude AE is drawn from vertex A. I'm not going to label because I want to simulate you labeling it yourself, but I'll label it later. Which statement is always true? That's a lot of ratios. CE over AE equals AE over ET, or AE over CE equals AE over ET. I'm going to eliminate that one. AC over CE equals AT over ET, or CE over AC equals AC over ET. Okay. Take your time to do this problem. I'm going to give you the minute. Not the worst strategy to make guesses at what the numbers might be. Actually, believe it or not, since the diagram, there's very little that could be violated, you might use an example answer that you already know the answer to and test them. Like maybe a 30, 60, 90 estimated triangle. Since it might be a 30, 60, 90, and in fact, it looks like a 30, 60, 90. Or a 3, 4, 5 right triangle, although you'd have to do a little bit of work with that one too. Or the 30, 60, 90, you have to do a little work anyway. So you could give an example triangle. Or you can make estimates on the lengths, but then your ratios are going to be just close to each other, but not quite right. So you have to say, oh, this answer is close, as opposed to this answer is exactly right. 12 seconds. There's a lot of strategies that can help you. And scale. Scale. Dismiss. Okay. Is this diagram drawn to scale? Triangle CAT, the measure of angle A is 90. Do those look right perpendicular? Yeah. So, fun fact, biologically speaking, there's questions about what we're good at seeing, what we're not good at seeing. And it happens to be that one of the things that we humans biologically are really good at seeing are right angles, things that are perpendicular. We're not good at seeing things that are perpendicular when they're at an angle. But if we actually turn our heads, or equivalently just turn the paper, then we can actually see it more easily. That CAT is a right angle. And AE, altitude, is drawn from vertex A. We know that an altitude, the only requirement is that it has to be perpendicular to the base. Do those look perpendicular? Again, humans are visually good at really seeing right angles. So AE is definitely perpendicular to CT. That's the only thing that can be violated. So this thing is definitely drawn to scale. So which statement is always true? You can actually estimate based on what's bigger, what's smaller in these answers. There is one that I saw. I was going to eliminate it right away. This numerator is AE and AE and AE, which means that the denominators, since the numerators are equal to each other and says equal, then the denominators have to be equal to each other. And CE and ET are definitely not the same size. Not in this diagram, at least. And it's drawn to scale because there's barely anything that could be violated. 90-degree angles, and that's it. So it's not choice 2. Let's see, choice 3. I don't know if I could eliminate these right away. I'm going to do this using the cheat code that I mentioned. I did left, right, and outside last time. This one I'm going to do outside, left, and right in case you prefer outside, left, and right to write the cheat code. But AC over CE, that's a big one and a small one. O equals AT over ET. That's a big one over a small one. Okay, or a big one-ish over a smallish one. And CE over AC, small over big, equals AC over ET. And that's a small-ish over big-ish. I don't think that that's going to be it. I suspect strongly because we're talking about multiple parts of just different triangles. So I don't think that's going to be it. So here's the cheat code though. This one, last one I did left, right, and outside in that order. This one I'm going to do outside, left, side, and right side. Put my bars, and I'm going to do the right angles first. I always do the right angles first. I actually prefer to do the outside, left, and right, but in that order when I do the cheat code. And I always start with the right angle because I could always visually see what the right angle is. On the outside triangle, the right angle is at A. On the left side triangle, the right angle is at E. And on the right side triangle, the right angle is at E. On the outside triangle, go for this angle here, C. Well, C is on the outside triangle. On the left side triangle, C is part of the left side triangle, so C corresponds to C. And on the right side angle, C is not a vertex of the right side triangle, so I might not know which one corresponds to it. So now I go to the outside triangle. This angle corresponds to itself on the outside triangle, but it's also part of the outside triangle. T is part of the outside triangle, so T corresponds to T. And now I'm missing, I don't know which angle necessarily corresponds to T on the left side triangle, but I'm actually only missing one vertex at angle C on the left side, which is why this cheat code is constructible. Triangle CEA, I'm missing A. And the right side triangle, AET, I'm missing A, EAT. Okay? So there's my cheat code. Vertex 1 corresponds to vertex 1 all the way down, A, E, and E in that order. Vertex 2 corresponds to vertex 2 all the way down, CCA. And vertex 3 corresponds to that TAT in that order, outside, left, and right. Okay? So choice 1, I have CE over AE equals AE over ET. Now, we might not know which triangles to use when we're analyzing this cheat code. And so the fact that we have AE appearing twice is actually a bit of a gift. Okay? It's a bit of a gift. I'm going to use the yellow because it's easier to see the highlighting here. AE is a gift for analyzing whether choice 1 is correct because AE is part of 2 different triangles. So AE is part of the left side triangle, is a side of the, when I say part, I mean a side. AE is a side of the left side triangle, and AE is a side of the right side triangle. So I have to be, if choice 1 is correct, it has to be that we're comparing the left side triangle and the right side triangle. That's what we're comparing, the left side triangle, the right side triangle. Now CE is on the left side triangle, CE. So this is CE, this is 2 and 1 on the left side triangle. And then AE rather is vertex 3 and vertex 1 on the left. And so this has to be the right side triangle. This has to be 2 and 1 and 3 and 1. And on the right side triangle, in fact, AE is, well, AE is 2 and 1, right? And ET is 3 and 1. It's actually written as 1 and 3, but 3 and 1 and 1 and 3 are the same thing because they're not directed sides. So this actually matches the cheat code. So the answer is that. Okay? I will tell you what caused me to eliminate choice 3 in my work. What caused me to eliminate choice 3 in my work is that I saw that there was AC, CE, AT, and ET. Now, only one of the triangles has ET. So that had to be the right side triangle. This is 1 and 3. Okay? So I had to look to see what triangles correspond, what triangles had sides that are part of triangle 3 and triangle 1 that correspond to each other. Some other side of triangle 3 has to appear. So AT is not a part of triangle 3 of the right side triangle. CE is not a part of triangle the right side triangle. I'm sorry, AT is a part of the right side triangle. CE is not a part of the right side triangle. AC is not part of the right triangle. So I see that AT has to be another part of the right triangle, which is 2 and 3. So now we need something else part of another triangle, and it has to be 2 and 3, and 1 and 3, or 3 and 1, and 3 and 2, in reverse order. But we see AC could be part of the outside or the left side triangle. AC, so this could be the left side triangle, because this would be 1 and 2 on the outside triangle. So this has to be the left. And so this has to be the left 1 and 3. But 1 and 3 on the left is EA. So this would have to be EA. So that makes this answer 1. That was a bit of a chore. I got lucky that I analyzed choice 1 and it worked. And AE was the key that I used to eliminate that one. Okay? To eliminate choice 4. And also to get question right. That's question 1 correct. All right. That was a lot. The cheat code though is an extremely useful cheat code for all right triangles where the vertical drops from the right angle. Okay. Super useful way of doing that problem. But let's hop over to número 19, number 19. A sandbox in the shape of a rectangular prism has a length of 43 inches, a width of 30 inches, and Jack uses bags of sand to fill the sand box to a depth of 9 inches. So each bag of sand has a volume of 0.5 cubic feet. What is the volume, the minimum number of bags of sand that must be purchased to fill the box? 14, 13, 7, or 4. That's a big range. It's up to 3.5. So there might be some things that you could do. And I will also point out that these are probably having to do with a something times 2 type of situation. But I will give you your minute to make your estimates for this problem. Pay attention to units. Pay attention to units. It's rare that they ask you to mess around with units on a part 1 question. They usually do that maybe on one problem in a part 2, 3, 4. And in fact, it's only about 30 to 40% of the Regents in geometry that they really ask you to dig into units. But I see that the sides are inches. I see that the volume of the bags are cubic feet. 20 seconds. And I'll tell you where I got my estimate. Okay, so where I got my estimate, this is my rough estimate. Okay. I know that I do know that 12 inches is a foot, and you actually do need to know that, although you can escape it, but it's not a good escape. Using anything else than knowing that 12 inches is a foot makes this problem really tough. But my rough estimate, I see that 30 inches is actually 2.5 feet. It's actually exactly 2.5 feet. But my 43 inches is not exactly roughly 36 inches plus another ish. So it's around 3.5 feet. 48 inches is 4 feet, roughly 3.5 feet. And then the height is 0.75 feet. And so I go to my calculator and I do my rough estimate. And this is great because it's going to give us 50% chance of getting it right, even if we don't actually know how to do this problem. 9 inches is 0.75 feet, 3/4 of a foot. Or if you don't know how to do 3/4 as a decimal, you could literally write 3/4. This is my rough estimate. It's 6.56 or something. That's the cubic feet. Now I know the bag of sand is 0.5, so I divide that by 0.5. Now I know I need at least or around 13 bags of sand. Believe it or not, this is well. First off, this eliminates 7 and 4 completely, and it might leave 13 and 14 as a rough answer. But fun fact, there's already enough to say we can eliminate one of the choices. In fact, I'm going to tell you to say it in the chat. The only reason I'm not going to tell you right away until the end, if I remember, let's hope I remember, why we can eliminate one of the two choices, choice 1 or choice 2, is that often if I tell you how to eliminate the answer, you just kind of move on, but then you move on not knowing how to actually do the problem, when this exact problem might not necessarily appear on the Regents. You don't want to do that. So I'm going to tell you how I eliminated one of the two choices, choice 1 or choice 2. This is my rough answer, but here's what it is. I actually get the volume in feet, So that's what I did when I was doing this practice, Regents. Okay, let me get that Regents back out here. Okay, so if you scroll up to the formula sheet, okay, or scroll down to the formula sheet rather. Okay, scroll down too far. Okay, there is unit conversions. And if you're on the new Regents at this point, which starts next year, the unit conversions may be different. We don't know yet because they won't give that out until the beginning of next year. They've already created the formula sheet for algebra. We don't know what the formula sheet for geometry is going to look like, if it's going to be the same one or if it's going to be different. But I want to point out here, inches to feet is not here. But there is inches to centimeters, inches to meters, and there's no meters to centimeters. So either you have to know that there's 12 inches in a foot, or you have to know that there's 100 centimeters in a meter, and go chase around numbers until you get to 12 feet in an inch, and 12 inches in a foot. Or you just need to know 12 inches is equal to 1 foot. I don't, you know that in chemistry, you kind of have to know a lot of this stuff, and in physics, you definitely have to know a lot of this stuff, but I don't know if I'm fully an enemy of having you know some basics of common knowledge, but there are cultural issues, which, if you happen to come from a country that uses meters and then you come to the US and you come to the US two months before the Regents and you hadn't learned yet that there's 12 inches in a foot, that's tough, but it is an important thing to know. Okay, so how do I go about it? 30 inches over 12 feet, over 12 inches per foot is equal to the number of feet. So is equal to 2.5 feet. And the point is that this is the actual number of feet. So I don't actually have to worry about getting that number because I can let the calculator handle it. I could just do 30 over 12. Okay, so here's my diagram, by the way. Big box. Okay. So I got a length of 43 inches. I got a width of a width of 30 inches. And I got a height of 9 inches. So the width is 30. The length is 43 inches, 43 over 12 feet. And then the height is 9 over 12. So this is equal to the volume in cubic feet. And if you're wondering where I got the volume formula from, well, the volume of a general prism is right here. 1/3 base. Oh, I'm sorry, base, just not 1/3, just plain old base times height. Volume is base times height. And the base is a rectangle, so length times width. So the volume of a rectangular prism is length times of a box that's a rectangular box is just length times width times height. So that's where I got that. And you do need to know that the area of the base is a rectangle, length times width. There's your parallelogram, base times height. Okay. So this is the volume of the prism, and I get that in my calculator times 43 over 12 times 9 over 12, and I get 6.71875. So the number of bags is equal to the volume divided by the volume per bag. So this is equal to 6.71875 divided by 0.5. $13.4375. Now, the wise ones among you might realize that 13.4375, we normally round that down. Why do we round that up? Why do we round that up? And by the way, I still have, because I'm my moderator, I still see the chat, so please do type in the chat if you have any questions or comments, whatever you have. So, but that said, why do we round up? Well, it's because once you open a bag, you have to use it, or you've already purchased it. So when they say the minimum number of bags, they actually require you to round up in this case, and they keep doing this in the Regents, and this is not tricking you. This is literally testing if you know that if you have 13.4, that you need 14. That's a valid real life application problem. So the answer is 14, and I said that I would tell you why I could eliminate 13. Here's the reason why I could eliminate 13. Because I knew my original rough estimate was a little over 13, but I said 2.5 times, or roughly 3.5 times exactly 0.75. But this roughly 3.5 is because I estimated the width to be roughly 3.5 feet. But 3.5 feet is 36 plus 6 is 42 inches. The width is slightly bigger than 3.5. So my rough estimate was already 13 and change, so I already needed more than 13. I already needed more than 13 in my rough estimate. So that's what I recommend when you make an estimate. Not only make an estimate, but decide, is your estimate above or below what you think the actual answer should be. And in fact, you often can say the actual answer is 100% definitely above or 100% below, or even just close. And my estimate is definitely close, but my estimate is definitely low. The actual answer is going to be definitely slightly higher. Definitely slightly higher. 14 is the only answer left. All right, numero 20, number 20. Parallelogram EATK has diagonals ET and AK, which information is always sufficient to prove that EATK is a rhombus. So I'm going to give you your minute. Draw your diagram. I don't know of anybody who can get this answer right without drawing a diagram. Remember, again, the vertices have to be given in order, EATK. So when you draw your diagram, label it so that you actually end up finding out. The thing that gets a lot of students wrong with this question is they think that ET and AK must be sides of the rhombus. But if you draw it using the order EATK, you're more likely to get it right. 30 seconds. 30 seconds. 20 seconds. Listen, I know you could do really well on this. I know that you could do really well on this Regents. I believe in your abilities. I have full confidence in you. Everyone watching this video can definitely pass the Regents. You just got to do the work that you need to do to get the answers right. You need to draw diagrams. You need to show work. That fight that you, if you're the kind of student who fights about showing work, trying to get the teacher to not make you show work, I think you need to stop that fight and you need to start showing work. And I think that's a philosophy you need to bring with you to next year. Not fight the teacher when they tell you to show work. Okay? Show every bit of work as humanly possible. So parallelogram EATK, diagonals ET and AK. But we know that it's a rhombus, so might as well draw it as a rhombus. And I have advice. If you know that it's a rhombus, you can draw it vertically because we, as humans, have the ability to see perpendicular lines much more easily than we have to non-perpendicular lines. And the property, like rhombuses have so many physical properties. That was, I don't know whether that one got drawn as an arrow, but sure. I think the little bit of shake that I had in my hand made it an arrow. But the rhombuses have so many properties. Diagonals, already being parallelograms, diagonals bisect each other. But they're also perpendicular to each other. Being rhombuses, the sides are congruent. All of the sides are congruent. The angles are bisected. One arc on each of those. One arc with a dash on each of these. That's a massive amount of information. And of course, the four triangles, the four smallest triangles that you see created are all right triangles. And by side, 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 they're all congruent. And then the top and the bottom big triangles are congruent isosceles triangles, and the left and right triangles are congruent isosceles triangles. It's a massive, massive amount of symmetry. In fact, when we do a construction problem later on in this test, ruler and compass constructions, I'm going to actually talk a little bit about rhombuses, because almost every construction problem has to do with rhombuses. In fact, I was thinking about doing a video on something I was talking about with my fiance, who's my moderator right now. Say hi to Jelly, please. I was thinking about something that I was thinking about naming construction kung fu, because there's only a very small list of things that you need to know how to construct before you could actually do every single construction problem. And not only that, you can actually do them like with software in a few seconds, which is why I imagine the mouse moving around the block or with the compass, and that's why I'm thinking about calling it construction kung fu. If you want to see a video of that, definitely let me know. Construction Kung Fu. Just type in Construction Kung Fu into the chat or into the, if this is afterwards and you're not seeing it live, put it into the comments. Okay, which is enough to prove that this EATK is a rhombus. We already know that ET and AK are diagonal, so ET and AK. Well, let's see. They said EA is perpendicular to AT. Now, you might think that this is enough, but if you have a parallelogram with perpendicular sides, so this is EA and AT, this is perpendicular sides. This implies that you have perpendicular sides. This does not imply that you have a rhombus. This implies that you have a rectangle. So choice one implies that you have a rectangle, but not necessarily a rhombus. Squares are rhombuses, but you don't necessarily have a rhombus. This is sufficient to prove. You have to prove that it's always a rhombus. Choice EA, EA is congruent to AT. EA is congruent to AT. Well, parallelograms always have congruent opposite sides. But now EA congruent to AT implies that you have congruent adjacent sides. This is looking good. This is really looking good. EA congruent to AC. This is really looking good, because now you have congruent adjacent sides. It doesn't restrict the diagram too much. So I think it's choice two. In my paper, I know, but I think it's choice two. This is looking good to me as a fake student me. When I say fake student me, I'm simulating myself as a student. But since I'm not sure, I go through choice three and choice four. ET congruent to AK. This is congruent diagonals. And remember, we only know that it is a parallelogram. If you have congruent diagonals on a parallelogram, this again implies that it's a rectangle. So this is a parallelogram. This is a parallelogram with perpendicular sides. That means rectangle. And this is a parallelogram with congruent diagonals. This implies that it's a rectangle. Okay? Not necessarily a rhombus. And then choice 4, ET, congruent to AT. Congruent to AT. ET congruent to AT. Well, that implies that the top triangle is isosceles. And it implies that the bottom, when I say the top triangle, I mean ETA, that would be isosceles. And it implies, since AT is congruent to EK automatically in a parallelogram, that implies that triangle ETK is also isosceles. But that's always true. Anyway. I'm sorry, that's not always true anyway. That only implies that we have isosceles congruent top and bottom triangles. And what's not always true is that the triangles are isosceles. That's not always true. But it implies that now the triangles on top and bottom are isosceles, but it doesn't restrict the length of EA. So this thing, you could open up angle ETA as much or as little as you want, which means that you create a length of EA that is as long or as short as you want, up to twice the length of ETA, ET plus TA. And so that doesn't restrict EA, it doesn't restrict it from being a rhombus. This is just still this is now an overstructured parallelogram. This is an overstructured parallelogram. That's all it is. Just a parallelogram with a bit of extra structure. It doesn't make it anything special other than parallelogram. So the answer is actually choice 2. Okay? This one I had to go through, as a fake student me, I had to go through process of elimination. In fact, choice 2 did imply that this was a parallelogram because you have congruent sides, congruent adjacent sides on a parallelogram. So that makes it so that all 4 sides are congruent, which is the condition that you need for a rhombus. All right, número 21, number 21. We're going to use scale on this one. Did I lose the choices here? That's interesting. I'm going to go to 21 over here. I know this one was a big diagram, so I must have lost the choices. Let me zoom in a little bit. Okay. Okay, now we have it. So in the diagram below, ABCD is parallel to EHK. Now I'm simulating myself as a student, but I'm also sometimes not simulating myself as a student, meaning I want you to remember to do the labeling yourself. That's why I don't always do the labeling before giving you the minute, because I want you to simulate you yourself taking the test. So you would have to do the labeling, but this one I'm doing the labeling, simulating myself as a student. ABCD is parallel to EHK, and also MBHP and NCLH are drawn such that BC is congruent to BH. BC is congruent to BH. That creates a whole lot of structure. If the measure of angle, and they look the same size, so far this is drawn to scale. The lines that are straight look straight, but they always have to be, so that we have the same conversation. And BC and BH look like they're the same size, so this is drawn to scale. And if the measure of angle NCD is 62 degrees, this is also drawn to scale. That looks like a 62 degree angle. This is drawn to scale. And then, so they ask you, what is the measure of angle PHK? PHK. Put a dash there. Angle with a dash there. Now, angle chase, angle chase, angle chase until you get as far as possible. This is the kind of problem where a lot of students say, I don't know how to do this problem. But just do what you can. Geometry problems are like that. You have to often angle chase or chase for a while until you get the answer that you're looking for. Don't think that you're going to get the answer in one step. That's not how Regents geometry problems are. In fact, Regents physics problems are like that. One step. If you could find the one step to do it, unfortunately, sometimes you might need 2 steps if you don't know the one step. But geometry problems, you often need 5, 6, 7 steps. Keep chasing, chasing, chasing until you're done chasing because you don't know where else to go. Using correct math, using correct math. And if you don't know how to do this with correct math, we confirm that it is drawn to scale. Use scale to get the problem right. All right, let's get that minute. Take that minute and see if you can get the problem right. $27. Man, scale is making this problem feel really nice. So if I got a 1 in 3, if I eliminate one choice in all 24 questions, I got a 1 in 3 chance of getting every single question right. Remember this: 24 questions. If I wild guess, I got a 1 in 4 chance of getting 24 questions right. That's 6 questions. But if I eliminate one choice in all of them, now I have a 1 in 3 chance of getting each of 24 questions right. That's 1/3 of 24 is 8 questions right, just by eliminating one answer. If I eliminate 2 incorrect answers, then I have a 1 in 2 chance of getting any question right, and that's one half of 24 is 12, and that's already basically a passing grade. And if I eke out a point here and there, counting the ones that I do know how to do, that I might think I don't know how to do, but I chase until I get the right answer, I might actually end up eking out a very passing grade. And if I show work on the part ones, if I know how to show work on the part ones, that I show work on the part 2s, 3s, and 4s, then I get massive points. Okay? So now this diagram is drawn to scale. So if I use scale, PHK, actually PHK looks kind of similar to D to NCD. So if I say something close to 62, I think that makes sense, but 62, 56, and 68 are pretty close to 62. But 118 is entirely too far away. Drawn to scale, I've already got a 1 in 3 chance of getting it right. Now, how do we do this problem? Angle chase, angle chase, angle chase. First, I'm going to use the fact that ABCD is parallel to EHK, making this angle by this angle 62 degrees. Also, this angle 62 degrees. Now, and this angle 62 degrees. Okay? So how do I get these? There's a lot of ways to get each one of these. Angle CHK, which was the first one I labeled, is 62 degrees because of corresponding angles. It corresponds to angle NCD. Corresponding angles are congruent. And then these other 62-degree angles, I either got them via alternate exterior angles being congruent or vertical angles are congruent. Okay? So that's a good place. I got this angle, 180 minus 62 is equal to 120 minus 2 is 118 degrees. And that's where the 118 choice came from. So put a dash on this one. No, put 2 dashes on this one because I already have a dash. Okay. 118 degrees. So that's because straight angles measure 180. So adjacent straight a linear pair, adjacent straight angles forming a straight line. In other words, a linear pair are supplementary. So that makes this over here 118 degrees. So you might say, but that doesn't give me that angle with a dash in it. But I got something, I've eliminated a bunch of degrees of freedom now. If I get this angle over here, which I'm going to put 3 dashes on, I have, for now, actually I'm going to erase that. If I get that angle, then I got the other angle. So like, in other words, now I have 2 different avenues of getting the right answer. I can get different angles to get that final answer. So I'm done angle chasing just from, well, there's a lot more that I could label, but I'm going to stop angle chasing now to start using things that I know. This again, you can keep going, till you're done. I strongly advise that because there is more that you could do. But I'm going to start now. I'm going to use the fact that this side is counter to this side. Remember this. In middle school, in elementary school and middle school, we trained you to eliminate irrelevant information. And I think, personally speaking, that's one of the worst pieces of advice that we could have given you. The way it was taught is terrible. The way it was taught is terrible. I'm going to repeat that for teachers. The way it was taught is terrible, because what we taught students is to start eliminating mathematical information from a problem. But then it turns out that in high school, we almost never give you irrelevant mathematical information. Things that are irrelevant involve, like, did you buy a cantaloupe or did you buy a watermelon? That doesn't matter. But it's almost always the case in the math problem, right? It's almost always the case that every bit of mathematical information in every problem is relevant. In fact, there are many textbooks where 0 problems have irrelevant mathematical information in the entire textbook. And almost every textbook, 99% of problems have all mathematical information relevant. That's just the way that nature makes problems. It kind of is that way. And kind of. And that's the way we think. So we kind of make it that way. So BC congruent to BH makes triangle BCH an isosceles triangle. And look at that. Now we know that I need to label that with a blue single arc with no dashes. The base angles of an isosceles triangle are congruent. That's 62. And that makes that, by vertical angles being congruent, that makes this 62 degrees. And now we have 2 adjacent angles. I'm going to call this, the measure of angle PHK. So we have the measure of angle PHK, which is in a mystery number, plus that 62-degree angle is equal to the big 118-degree angle. And I can just subtract 62, and I got that the measure of angle PHK is equal to 118 minus 62 is 68. No, 56. Sorry, 56. Can this one be done by plugging in and checking? It actually can be done by plugging in and checking. You just guess which one you think is right and see where it leads you. If it leads you to a contradiction, then you know it's wrong. So like if you labeled PHK as, let's say you thought the answer was 68, like I just said, label it as 68, chase until you get a contradiction to the 62-degree angle, or till you get any kind of contradiction at all. So you can actually do this one by plugging in and checking. Very valid way of doing problems. Número 22, number 22. Triangle YEG and triangle POM are 2 distinct non-right triangles such that angle G is congruent to angle M. Which statement is sufficient to prove that triangle YEG is always congruent to triangle POM? Is it angle E and angle O are congruent, and angle Y is congruent to angle P? Or angle YG is congruent to PM and YE is congruent to PO? Or there is a sequence of rigid motions that map angle E to angle O and side YE to side PO? And also, there is a sequence of rigid motions that maps to map point YG onto point P and also side YG to PM. Oof. This one, I think, this is one of those that I think, because it's one of the last Regents, I think somebody wanted to put this problem in. But there's things that can be said about it. It's not undoable. For a lot of students, it's really difficult, and it is a number 22. Later on in the multiple choice, the problems tend to be a little bit tougher. But there's a lot that you can say, okay? So I'll give you that minute. And there's at least one that I can eliminate. Giving me at least a 1 in 3 chance of getting the question right. Yeah. Worth it. Give you 46 more seconds. Is it worth it to draw a diagram? Yes, always. Always draw a diagram. Always draw a diagram. Always worth drawing a diagram. If they didn't give one to you, draw a diagram. "25 seconds. 7 seconds. All right. And by the way, if you're wondering if I have any other resources for students, if I don't have them already in the description, I will put them there in uh, after this video is done. Uh, I did put them in, but you know, first time I'm doing this live, and I think that I typed them in and then didn't finish typing it in, or I didn't hit save or something like that. So first time doing a live video though of this region, so definitely, you know, whatever. But here, triangle YEG and triangle POM are two distinct non-right triangles. I would literally just draw the diagram. So they said two distinct and they said non-right triangles. So, but in this case, I know that we're trying to prove that they are congruent. So might as well prove, create two triangles that look congruent. Okay, so can I just copy and paste this one? Let's see. And they said prove triangle YEG is always congruent to POM. Yes, the name of the vertices order is relevant. Y, E, G, and order P, O, M. In that order. And I will say this for teachers, if you're wondering, do you have to give the vertices in names in order? Yes. Can you assume that they're given in order? Yes. Do I hate the fact that I said that? Yes. I'll tell you why I hate that. There have been a lot of geometry problems given where there's a typo, where the vertices are just not given in the right order. And they haven't eliminated those questions. That's me wagging my finger at the test makers, okay? Because that's bad policy. If you teach something if you teach students that something has to be true, the vertices have to be given in order, then make sure that you do it yourself. You can't have them assume that something is true and then violate that in the middle of a test, especially not in the middle of a Regents. Okay, so yes, the vertices do have to be in order. Students, yes, you should assume that they're given in order. So here's the why I actually eliminated choice 1 right away. They gave me that angle G is congruent to angle M. Put 1 arc on those. Choice 1 gives me 2 more angle congruences. That gives me no side congruences. So the triangles in principle could be any arbitrary size. That makes the triangle similar, but it doesn't make them congruent. It makes them similar, but not congruent. This means that triangle YEG is similar to triangle POM. Okay? So that's why that's violated. Now, the second one, YG, is congruent to PM, and YE is congruent to PO. Now, I'm going to give this label the sides that correspond to each other with 1 dash, with 2 dashes, and with 3 dashes. So YE corresponds to PO, YEG corresponds to OM, and YG corresponds to PM. And I put 1 dash, 2 dash, 3 dashes through. Here, for choice 2, they said YG congruent to PM, and YE congruent to PO. Notice that YE and PO are the non-included sides. So this gives a side. If you go in a clockwise direction, counterclockwise direction, we have a side, and the non-included angle. So we don't put the angle in between the side and the side, we put it at the end. This gives side-side angle, which we know is a false statement. Or if we start from the angle, we get angle, side, side. Now, I just want to be clear here, and I'm going to leave this right here on this video. I want to be clear. We don't fail to teach you side, side angle or angle, side, side because it happens to spell a certain word in that order. Because if it was true, if it was a true theorem, we would love to be able to teach it to you this way because you'd remember it. But better to remember that the one that spells that word is not a theorem. In fact, it's a false statement because it's the ambiguous case. It actually turns out to not be a theorem. You could find 2 triangles that satisfy ASS or equivalently SSA that are not congruent. So SSA is a false congruent statement, and it's one that catches students all the time. That's why this one is wrong. Okay? Let's go for the third one and the fourth one. There's a sequence of rigid motions that map angle E to angle O and side YE to side PO. So, and the fourth one, there's a sequence of rigid motions that maps point Y to point P and YG to PM. So what's wrong with them? What's wrong with one of them? This one, the third one maps angle E to angle O. I'm going to put a dash with a arc with a dash through it, an arc with a dash through it. So those are congruent to each other. And also, the choice 3, YE maps to PO. So that makes YE congruent to PO. And notice that that gives angle, angle, and then the non-included side, so side. Not angle, side, angle. Not angle, side, angle. Angle, angle, side. Angle, angle, side is a congruence relation. So that makes these triangles congruent. What's wrong with choice 4? And people argue about choice 4, but it's not poorly written. It's a tough problem. 22 out of 24 multiple choice. It's a tough problem. So what's wrong with it? A lot of students see it and they think it's right because they think it says the same thing as choice 3, and it doesn't. It says a sequence of rigid motions that maps point Y to point P, not the angle, but the point itself. So this one, I'm going to map the point onto the point, and also YG to PM, which we labeled. I'm going to put one more colorful dash on it. So the bottom side and the top side are the same. Well, you might think that that makes this thing rigid. After all, we already are given that angle G is congruent to angle M, but the truth is that you could take E and just fix it. And you could take point O and just launch it that way. And that leaves angle M unchanged. It leaves side PM unchanged, but it extends the length of OM and it extends the length of OP, meaning making triangles that are not congruent to triangle YG. So that's the problem with choice 4. So the answer is choice 3. Even a lot of teachers get this question wrong. This is a tough problem. I would make this number 24 because I think it's one of the toughest. It's in my opinion, one of the toughest multiple choice questions that I've seen before. But if you got it right, congratulations. I really appreciate it. Let me know that you got it right because it means you're in a really good place for the Regents. 23, they gave us a diagram. I would start thinking about scale if you're doing this problem. In the diagram of triangles ABD, and CBE below, side AD and CE intersect at F. That's definitely true. And angle ADB is congruent to angle CEB. Okay, I labeled that as a simulated student for myself. I would do that yourself, even if you're not with me. Which statement cannot be proven? Is it that triangle ADB is congruent to triangle CEB? Is it that angle EAF is congruent to angle DCF? Or is it that triangle ADB is similar to triangle CEB? Or is it that triangle EAF is similar to triangle DCF? Cannot be proved. There's an awesome elimination that takes this down to at least 2 choices, but I'll give you the minute to think about what that is, and I'll give you a hint. It's about choice 1 and choice 3. Or it's elimination, or yeah, it's elimination. 23 seconds. You can start using scale, although this is one of the places where teachers start to fight Kumite style about scale. So why do teachers fight Kumite style about scale on this one? So the question is, doing my knees to get ready to fight. So the thing is, do angle ADB and angle CEB look congruent? Absolutely. Do the intersections happen where they said? Absolutely. But that's all that's said. So why do teachers fight on this point? Well, no lengths are given, which means that there's nothing in the problem forcing any lengths to be what you want them to be. So triangles can get bigger or smaller, but they drew them to look like they're the same size. So that's the difficult thing. So this is where something interesting can be said. Choice 1 and choice 3. If triangle ADB is congruent to triangle CEB, then the triangles are also similar. Vice versa, if the triangles are similar, then they may or may not be congruent. But if the triangles are not congruent, if you can't prove that they're not congruent, then you definitely can't prove that they're, I'm sorry, if you can't prove that they're not similar, then you can't prove that they're not congruent. Which means that if you can't prove choice 3, says cannot. If you cannot prove choice 3, then you also can't prove choice 1. And they said cannot. So choice 3 being false implies that choice 1, or choice 3 being unprovable implies that choice 1 is also unprovable. This can't be the answer. And let me draw the arrow in this direction. This would imply that choice 1, if choice 3 being the answer, would imply that choice 1 is also the answer. Let me draw a better arrow. Cannot. Which can't be true. You can't have two correct answers. Okay? So how can we prove that they are similar? Well, these two triangles, ADB and BCF, have a common congruent angles because it's given to you. And they also share angle B. So by the reflexive property, angle B is congruent to itself. By the angle-angle postulate, these two triangles are similar. Okay? So that implies that either the triangles are congruent, which means that these two are false, which means that these two can be proved. So here's the thing: if this triangle is congruent to this triangle, that makes angle A congruent to angle C, and that implies that. But it also makes, well, okay. So let me actually do the way I did it, because there's a lot of implications. If you can prove that this triangle is congruent, that actually implies that all of them can be proved. So number 1 should be eliminated. But here's the thing: we're going to do some angle chasing. Can you prove that angle EAF is congruent to triangle DCF? So this angle is part of the triangles that we've already proved similar by the angle postulate. So this angle is congruent to this angle, and that's choice 2. We proved that it's true. CPSTP. Corresponding parts of similar triangles are proportional, or corresponding angles of similar triangles are congruent, whichever you prefer. So we just proved it. And then triangle EAF is similar to triangle DCF. So that one takes a little bit more angle chasing. This angle, though, being an angle linear pair with angle BEC, and this angle being a linear pair with angle BDA, supplements of congruent angles are congruent, So these two angles are congruent. So that this triangle here, triangle EAF and angle DCF are similar by the angle postulate. So that we just proved it. So that one can't be it. So it has to be choice one. Again, I'm going to say this though, choice one being true, if we can prove that these two triangles are congruent, that means that all of them can be proved. Just that one being true implies that all of them are true or are provable. If just that one being provable implies that all of them are provable, which means all the answers are false. However, all the other ones are provable independent of choice one. Therefore, it's the only one left. Now, why is that choice one has to be not provable? Again, there are no lengths that are a restriction. There are no lengths that are restricted. So you can't have congruent triangles. That one I think was one of the tougher problems, to be honest. I think so. So number 24, numero 24. All right. And this is the last one in the multiple choice. It's supposed to be a tougher problem. Let's see if it's tougher than 22 and 23. A small town is installing a water storage tank in the shape of a cylinder. The tank must be able to hold at least 100,000 gallons of water. The tank must have a height of exactly 30 feet. 1 cubic foot holds 7.8 gallons of water. Thank you, Regents, for giving us that number. Let's see if that is in the formula sheet. Let's see, cubic feet. I don't see it, but they do have liters to cubic centimeters. You could do some unit chasing to prove that. I don't think that's fun. They gave us this, probably relevant, right? So what should the minimum diameter of the tank be to the nearest foot? I would draw it. Let's give you the minute. 100,000 gallons of water, height of exactly 30 feet, minimum diameter. They're asking for the diameter. You know, you do a lot of problems with the radius in terms of, volumes. So take your 43 seconds, draw your diagram, do the math that you need to do, make any estimates. There are a lot of estimates that you can make here. I'll give you one estimate that I would use to make my estimate. And I did do that to make my estimate. And in fact, this could be used to make your estimate, and it will give you the correct answer with 100% certainty. Here's the estimate strategy. That's the minute. Here's the estimate that I made. So if 1 cubic foot holds 7.8 gallons of water, that means that, remember, if it was 10, 1 to 10, then you would need 100,000 divided by 10, which is 10,000 cubic feet. But 1 cubic foot only holds 7.48 gallons of water, which means you need slightly over 1/10 of 100,000 gallons, cubic feet of water, of volume. And so that gives you a nice quick estimate. So you could plug in and verify based on the volume formula for a cylinder. So we are working with a cylindrical tank. So with a certain radius, remember they give us also a diameter and a certain height. The height is exactly 30. The volume is equal to, according to our formula sheet, they luckily give us this one. They did say a general prism has a volume of capital B times H, which a general prism includes a cylinder, but they also gave us the volume of a cylinder. The volume equals pi r squared H. So V equals pi r squared H. Now, where do students lose points on this one? They gave us diameter, they want radius. Or they give us diameter, the formula wants radius. So a lot of students just stick the diameter instead of the radius, but we kind of know that that's illegal. Know what you know means you know that the diameter and the radius are not the same thing. Don't treat them as the same thing, but know that the diameter is double the radius and the radius is half the diameter to get the radius, okay? Because that allows you to get your estimate. And by the way, this estimate that I made, instead of doing 1 over 10, you can get the exact. You can get the exact by doing 1 over 7.48 times 100,000 on your calculator. And you get the exact volume, and then you could actually use that to get the exact dimensions. But I'm going to plug in some numbers now. I know that the volume is equal to 100,000 divided by, this is divided by 7.48 gallons per cubic feet. And this is my exact number, 100,000 divided by 7.48 is 13,668.98396. As I said, my recommendation for the Regents now has become to use the full expansion and then round at the end. So 13,368.98396. And now, so the volume that's equal to, so 13,368.98396 is equal to pi times r squared times the h is 30. So now we're going to divide by 30 pi. Put that in parentheses, divide by 30 pi. And we get that r squared is equal to that number. Divide by parentheses. This is another place where students get it wrong. This, just doing this makes it harder, knowing that you need parentheses in the denominator. You're required to have parentheses in the denominator because multiplication doesn't go before division. I know you said PEMDAS, M comes before D, and I am an enemy of that acronym. I like another one. But use parentheses to divide by 30 pi. You get r squared is 1.141. 141.849324. Take the square root, plus or minus, reject the negative, because r is greater than 0. It's a radius, it's greater than 0. So r is approximately 11.91. We're going to put that over here again. 11.91005144. We're going to multiply that by 2. So we need the diameter times 2. What's going on here? 23.82010289, and they said to the nearest foot. So we're going to round up 24. And there's our answer. Okay? This one could have been done by plugging in and seeing which one works, which one is true. So if the diameter is 24, that means that r is equal to 12. If the diameter is 12, that means r is approximately 6. If the diameter is 65, that means that r is approximately 32.5. If the diameter is 75, that means that the r is approximately 37.5. And if you actually just get the volumes using these numbers, and then divide by some, or multiply in that case by 7.48, you don't get 100,000. You only get 100,000 for 100,000-ish for choice 2. and I gave you your estimation process. Your 10,000-ish, again, is another way of doing it. The other way I suggested is getting the estimated volume and then in cubic feet, and then using that radius to get the estimated volume in cubic feet. All right. So if the multiple choice was tough for you and you need to take a little bit of a stretch, take a little bit of a stretch. If you need other snacks, get your snacks. Part 2, this is another place where they said diagrams are not necessarily drawn to scale. They say it 5 times on the test, on the algebra, geometry, and algebra 2. And then my recommendation, again, don't assume that a diagram's not drawn to scale. In fact, it's if you don't know whether the diagram's drawn to scale and you can't confirm it, you don't know how to confirm it, then it's actually safer to actually do assume that the diagram is drawn to scale, especially for the purposes of multiple choice questions. But even better than that is actually just confirm that it is drawn to scale. And it's almost always the case that you can confirm it. Even if you struggle with math, you usually can confirm it. You know what 6, 8, and 10 look like. You know what 5 and 15 look like relative to each other. You usually can confirm it. You know that a 90-degree angle is perpendicular. You know a 20-degree angle is very shallow. An 80-degree angle is close to perpendicular, but not quite. A lot of things you could say. So in this problem, número 25, number 25, in isosceles triangle ABC shown below. And I want to point out here, this problem looks like a multiple choice question, doesn't it? Which is why if you really can get a passing grade using the multiple choice, you should actually do work on the part 2s, 3s, and 4s and boost your grade to an 80, 85. If you can pass with just the multiple choice, if you can actively pass with just the multiple choice, you literally should be able to get an 80. There should be a gap in grades between in scores between there should be a peak below 65 and then there should be a peak above 80, and there should be really an empty space between 65 and 80 because of students who show work, but that gap doesn't exist. An empty gap doesn't exist because unfortunately so many students don't show work that so many students get these questions wrong. Okay, so show work, do as much work as you can, get the question right, get as many points as possible. The best thing about part 2s, 3s, and 4s is there's so much partial credit. It's so friendly. So in isosceles triangle ABC shown below, AB is congruent to AC. They told us which sides are congruent. I'm simulating myself as a student, so I'm doing the labeling for you. And altitude AD is drawn. I'm checking that this looks like an altitude, perpendicular, good. The length of AD is 12, good. And the length of BC is 10. So these look congruent. BC looks slightly shorter than AD because BD looks like half of AD, and DC also looks like half of AD, and BD congruent to BC. Okay, so this looks right. This is drawn to scale. And determine and state to the nearest cubic centimeter the volume of the solid formed by continuously rotating ABC about AD. So I'm going to give you your minute. Remember this, though, just as a hint, because a lot of students struggle with these problems. So if you already know this, you don't need this hint, so you could just keep going. But a lot of students who struggle with this problem don't know this. If you're continuously rotating, meaning literally going out of the page with an object, you're going to make a circular, an object with circular parts, which means you're creating cylinders, you're creating cones, you're creating spheres. You might be creating like combinations of cylinders and cones, combinations of cylinders and spheres, combinations of cones and spheres, but you are creating objects with circular parts. You're not creating like rectangular prisms. 20 seconds. So think about the object that you're creating and try to find a formula on the Regents. 8 seconds. All right. So if we're rotating continuously around AD, I imagine what I like to imagine is I like to have a literal drill going through around this, through this, and this is a drill bit at the end. It literally, if I'm drilling into a piece of wood, the piece of wood gets drilled into it by this triangle, but spinning immensely fast. And when it's spinning immensely fast, you actually see that it makes something that looks like a blurry cone. And in fact, that is what's created when you rotate around BD. You get a cone. So according to the formula sheet, there is a formula for the volume of a cone right there, v equals 1/3 pi r squared h. There's the formula that we're going to use. V equals 1/3 pi r squared h. And another place where students get stuck, if you get to that point, v equals 1/3 pi r squared h, but you use the wrong measurement, you get partial credit. Unlike the multiple choice, 3 points right there. So a lot of students use the diameter instead of the radius. The radius is 5 and 5. R is equal to 5 and h is equal to 12. And but some students use 10 or something like that because they use the diameter instead. Partial credit, points. Remember, partial credit on a 2-point problem is 1 point. That's a half a multiple choice. So why do I say don't focus on the multiple choice? Because just by using the correct formula with even the wrong number, you get half a multiple choice question right for free. So v equals 1/3 pi, r is equal to 5, 5 squared times 10. And now they said determine the state to the nearest cubic centimeter. To the nearest cubic centimeter. I don't have to get this answer, like in terms of pi. I can get it from the calculator. When they tell you to do it on the like as to the nearest whatever, you could just throw it into the calculator right away. 1/3 times pi times r 5 squared times h. Did I say 10? I meant 12. 12. And this number might actually look familiar to you. 314.159265. These look like the digits of pi, just with the decimal shifted over. And the next digit would be a 3, but the next number would be a 5. That's why there's a 4 next to it. And now my recommendation for these tests now has become to write the entire decimal from your calculator and then go around to what they want. V is approximately nearest cubic centimeter, 314. Notice I didn't write the units. They gave me the units all in centimeters and they wanted it in cubic centimeters. I didn't write the units because on this test, if they gave you the units, you don't have to give the units. So that's my answer. V is approximately 314. Sweet. Okay. Número 26, number 26. And I'm going to make an estimate for this one too. I recommend making estimates for all of these. The diagram below models the projection of light from a lighthouse L. The sector has a radius of 38 miles and spans 102 degrees. Determine and state the area of the sector to the nearest square mile. Lots of partial credit here. If you're wondering, I'm not going to simulate now. I'm going to let you do the work for a minute, but lots of partial credit to be had here. If you don't think you can get it right, do something anyway, because unlike the multiple choice, you can get partial credit. 1 minute. Do what you can. Do what you can. Just go at it. I believe in you. I believe in your abilities to get something, get some points out of it. I would recommend doing an estimate. Like I said, recommend bringing your Weezer squeezer. For those of you who have asthma, asthma is cool. I'm going to use this inhaler. I recommend, again, when you bring your snacks, your coffee, or not coffee, or decaf coffee, or other drink, bring your meds that you need to bring with you, including an inhaler. Three, two, one. All right. I didn't want to simulate myself as a student because you got to get used to doing the work that you feel is proper. I'm going to do my estimate. I love my estimates because they're my answer checks. Do you have to write down your estimates? I don't think so. But I always do estimates on part 2s, 3s, and 4s. I see that this sweeps almost a little bit more than 1/4 of a circle. So my estimate is 1/4 of pi r squared. So 1/4 pi times 38 squared. Put that into the calculator. That's my estimate. Use the calculator to finish that estimate, okay? Why do I recommend estimates? Because they check your answer for you. And if your estimate, especially for studying, if your estimate is way off of the answer that you got, then either your answer is wrong and then you got, then you could go and fix your answer, or, so either your estimate is wrong, in which case the work in the problem fixes your intuition, which improves your score more than anything you could do in studying, or your estimate is so far from your answer and your answer is wrong, and now you've checked your answer. This is, in my opinion, a better way of checking your answer. So now let's do a quick vocab. Sector. Sector means a part of a circle plus the interior. Okay? Area. Okay? Plus the interior area. Whereas an arc is equal to a part of a circle curve without interior. Without the interior. So they asked for the sector area, so now I'm going to get an area. I need to get the area of this whole thing. So 1/4 of pi times 38 squared, I could even do my estimate, that's around 400 pi, if I do some rounding. Now, if I round the 30, check this out, for improved estimates, I know that 102 is slightly more than 90. So if I take my 38 and round it just a little bit to 40, then I square that. Well, 40 divided by 4 is 10. 10 times that 40 is 400 times pi is around 400 pi. And if I round pi down to 3, that's around 1200. These are really rough estimates. Now I round it down so that I'm a little bit further from the answer, so I could actually say it's a little bit more than 1200. And this estimate is going to be phenomenal. So I said that's, again, it's around 1/4 times pi times 40 squared. And I changed the pi to 3, 40, 400 times 3. I mean, this is a lot of estimating, but wait, if the answer is not close to 1200, I'm wrong. So I'm going to use the part over whole. Yes, I'm going to use the part over whole proportionality relation. This is K. I'm going to let K equal the sector area. I'm going to let A equal the area of the circle. Okay? And let's call this angle theta. So the part over whole, part of the circle in degrees, over the whole circle in degrees is equal to the sector area. Okay, so the part of the circle area divided by the whole circle area. That's the part over whole proportionality relation. I know that there's ways of, there's a formula out there like S equals R theta, S equal, K equals 1/2 R squared theta. S equals R theta is the sector, the arc length. K equals 1/2 R squared theta. I know you have that formula, but over 360. If you have the formula, no, that's not even, I'm giving you the formula for in radians, which is algebra 2. But then you have to multiply by 2 pi over 360. So, not a fan. I don't know. I'm not a fan of it when you're doing this in degrees. And especially since the part over whole proportionality relation is something that permeates algebra, geometry, algebra 2, living environment, chemistry, physics. And it's a theorem that really should be focused on as a whole unit. because you could do a lot of science and math in real life situations with just this. So the part of the circle in degrees is 102 divided by the whole circle in degrees. The whole circle measures 360 degrees. That's equal to the part of the circle area, which is this k that we're missing, and the whole circle in area is pi r squared, pi times 38 squared. So now we're going to cross multiply. I know you guys are fans of cross multiplying. It's your favorite. So 360k is equal to 102 times pi times 38 squared. Divide by 360. Divide by 360. And we get that k is approximately what the calculator says is that number. So 102 times pi times r 38 squared divided by 360. And we get 1285. Let's bring that into the screen here. 1285.33. So this is me simulating how I highly recommend doing it on the test now. Write the full answer, 330274. And now round to what they said, nearest square mile. So K is approximately 128. The 3 rounds down to 0, so 5. The reason I recommend it that way now, by the way, this is for teachers and students. It fixes the problem that a lot of students don't know what to round to. Like in class, they're used to putting it to the nearest 10th because their teacher likes that, or to the nearest 100th because their teacher likes that, or the nearest 1000th because their teacher likes that, or rounding early and often. And rounding early and often can get your answer to deviate from the correct answer if you round too many times. So if you use the answer as given in the calculator, then you actually work as a pattern to always give the answer in its full decimal and then always check for rounding. And if it's something that you always do, it's something that you never deviate from. Okay? So number 27, this is the one that I always teach on software. I teach it on software, and this is the one that I was talking about. Maybe I should make a video called construction kung fu. That's what I think I might call it. So this says segment CA is drawn below. Using a compass and straight edge, construct isosceles right triangle CAT, where CA is perpendicular to CT and CA is congruent to CT. So just to be clear, what we have to draw here, we have to draw a perpendicular line, could be up or down, and it has to be congruent to this one. This is not constructed, this is just drawn so that you see what it ends up having to look like. I do this to teachers again. I do this on software. I teach this on software. You would think that this doesn't translate to non-software applications, but it just absolutely does. Okay, I have had students excel. Many students excel in constructions. Excel in constructions just by learning how to do this on paper. And the truth is, for students out there, all you're doing when you're constructing these kinds of things is you're using a ruler as a straight edge, only draws straight lines but doesn't measure, and a compass, which is your only measuring device. Even though sometimes compasses have numbers on it, the only thing that a compass truly can measure without numbers on it, because remember, you're not using the numbers on the compass, you're not using the numbers on the ruler. The only thing that a compass can measure is lengths, and it can only measure congruent lengths. And how does congruent lengths help? Well, because if you have an isosceles triangle, you have congruent lengths. And it happens to be that the radii of circles are all congruent. That's actually, in fact, the definition of a circle. So I'm going to make, and it has to go through CA. That's what they said. Okay? Didn't mean to do that. I meant to do this. So that point T is somewhere up there, but I don't know where it is. And I know that it's somewhere up there on the circle because I have to have the length of CT be exactly the length of CA, which means that it's on this circle. Okay, I don't know where that point is though. So I have to find out where that point is. So this is where there's some clever use of the circles. I know also that the diagonals of a rhombus are perpendicular. So I'm going to create a rhombus. So I have this new point over here. And now I know that you're used to seeing constructions with dashes all over the place, that all that the dashes are parts of circles. So when I teach this to students, I force them to draw the entire circle and they never regret it. They never regret it because it takes 2 seconds to draw a full circle. Oh, by the way, what I also recommend is keep the compass still and turn the paper. But anyway, so I have this point here, and now I know that if I construct a rhombus with C as the intersection of the diagonals, then I've constructed a rhombus with its perpendicular bisector. So that's what I'm going to do. I know that a rhombus has 4 congruent sides. If I construct a circle, a giant, giant circle there, and I construct a circle, let me unzoom here, and I construct a circle through A, going to this point. Now, why did I do that? Because now I constructed, this is a radius of the triangle, the circle on the left. This is also a radius of the triangle on the left. Okay, but now CA is also a radius. No, this point, which only for the purposes of, only for the purposes of the problem, I'm going to label. How about D? Point D is radius DA is a radius of the left side circle, but radius AD is also a radius of the right side circle. So the right side circle and the left side circle are congruent. So any radii of either circle are going to be guaranteed to be congruent, which means that this radius of circle A is congruent to the other radii of circle D. Let's try that again. This radius of circle A is congruent to the other radii of circle D, and this radius of circle A is also congruent to the other radii of circle D. So I've constructed a rhombus, which means that the diagonals are going to bisect each other and are perpendicular to each other. And just to drive home the point, I'm going to measure this angle. Look at that, 90-degree angle, perfect 90-degree angle. I constructed with a compass a perfect 90-degree angle, which means that this point over here, now I got to get the name of it, T. This point over here, which I'm going to label T, makes a right triangle. So I'm going to now connect with A to form a right triangle. That side with that side. I'm going to label it orange now. And this line segment which I'm also going to label in orange. That is a right triangle with congruent radii that are therefore isosceles. Okay, so teachers, is this how I teach the problems? Absolutely. Absolutely. Teachers, does doing the problem on software apply directly to doing the problem on the Regents with a compass, ruler, and compass? Yes, absolutely. Because then the compass stops being this weird tool for construction. It just starts being a tool to draw good circles. That's all that a compass is. All these weird dashes floating everywhere, students get so confused with that, it doesn't work. So I've constructed the object that they wanted me to construct, and I leave all the marks that I drew. Every single mark that I drew, I leave it there. This is the full, complete answer. And if you don't believe that this is true, look at what happens if I move points. This is, no matter what I do with the points, this stays a perfectly right triangle, right isosceles triangle. Okay, if you want to see me do a video called Construction Kung Fu, Type construction kung fu in the chat. I don't know, or actually put it in the comments. Put construction kung fu in the comments. But número 28, number 28. On the set of axes below, congruent triangles ABC and DEF are graphed. Describe a sequence of rigid motions that map triangle ABC onto triangle DEF. Okay, so let's do that. So it helps to know the vertices, but it does say in that order, ABC onto DEF. So it has to map A to D, B to E, and C to F. Oops. So DEF in that order. Make that look like an E, make that look like an F. Okay, in that order. Can I map it another way? No. What if they're congruent? No. There is a way to get partial credit by mapping it wrong, because these happen to be isosceles triangles. But if you map it, do a correct mapping to the wrong vertices, you get partial credit. So if you see the wrong thing, you could still get partial credit. Okay. But I have to map A to D. Now it turns out if I look at the vertices, 2, 5, 7, 6, and 6, 1, and D, -5, 2, F, -1, 6, E, -6, 7. So D, E, F, I should have done it in that order, but okay. So if you happen to remember a rotating method, you might get the answer in one step. But if you don't remember a rotating method, the one piece of advice that I will give you is that you have to say, if you have to be specific. You can't just say translation. You can't just say rotation. You can't just say rotation by an angle. You can't say dilation. You have to be really specific. Okay. What specific transformation you're doing. So I'm going to give you the minute and see if you see a way to do the problem. "48 seconds. Okay. 15 seconds. Let's see if you see it. Think partial credit. Just think partial credit. This is a part 2 problem. If you get it partially right, you actually do get that, you can get a point. And imagine, partial credit means that it's wrong, right? Which means that your triangle doesn't map one onto the other. But, or partial credit might be right, but you didn't give enough information about the actual transformation that you're doing. So there's a lot of ways, a lot of ways to get partial credit. This problem is so much of a gift in terms of partial credit that it's really a bit unbelievable. Some students do a translation followed by a rotation. Some students do a rotation followed by a translation. Some students do a reflection followed by another reflection. There's a lot of ways to do the problem. It does turn out, though, that if you see every single coordinate, if you rotate by 90 degrees counterclockwise of a point x, y, this is the point you switch the x and the y, and you negate the first coordinate, -y, x. So if you happen to remember that rule, then you could actually do this problem in one step. A, 2, 5. Switch, if you switch the x and the y, 5, 2, and then negate the 5, the first number, you get D. That's a rotation by 90 degrees. Rotation, point B, 7, 6 to point E, -6, 7. Switch the 7 and the 6, 6, 7, and then negate the first number, -6, 7. That's a rotation by 90 degrees counterclockwise. C, 0.61, transform to point F, negative 1/6. Switch the 6 into 1, 1/6, negate the first number, negative 1/6. That's a rotation 90 degrees counterclockwise. So the answer, 90 degrees counterclockwise, is the answer. So rotation 90 degrees counterclockwise is a full and complete response. Okay? So, what if you didn't do it this way, though? What if you translated? Remember, you have to. Oh, and I didn't say about the origin. Oh, I almost messed that up. About the origin. I almost messed that up. So I hope you didn't skip to the next problem before I finished explaining. Because if you don't say about the origin, that's actually just partial credit. If you say rotation 90 degrees counterclockwise, and that's it, you actually just get two, you get 1 point out of 2. If you say 90 degrees about the origin, but you don't say counterclockwise, you get partial credit because you didn't say counterclockwise. If you say rotation 90 degrees, you do get partial credit, but you still didn't say counterclockwise and you didn't say about the origin. How else could this have been done? You could literally translate down 3 spaces and to the left 7 spaces to map point A onto point D, and then rotate 90 degrees counterclockwise about point D in that order. So that's 2 different transformations that you could have done to get the problem. Another one, you could have rotated 90 degrees counterclockwise about point A, and then translated down 3 and to the left 7. So there are a lot of ways that you could do this one. And there's also pairs of reflections that you could have done. It does turn out that rotations and reflections can mix. Okay. But number 29, numero 29, this one gets a lot of students consternation because this is like the similar triangles problem where the side splitter theorem doesn't apply, but they try to make the side splitter theorem apply. But clearly the EB and DC are not parallel to each other. So that's the advice that I'm going to give you here. In triangle ADC below, EB is drawn such that AB is 4.1, ACE is 5.6, BC is 8.22, and ED is 3.42. And then the question is triangle ABE similar to triangle ADC. Explain why. And you need words because they said explain. Okay? Again, I'm going to help a little bit before, if you need to mute me for just a second, but I'm going to point something out, the vertex naming, A, B, E, cheat code, triangle A, D, C. A corresponds to A, but E doesn't correspond to B. E corresponds to C, and B corresponds to D. Switch it, all right? The side splitter theorem doesn't apply here. EB and DC are not parallel, but it doesn't mean that these triangles are not similar. Okay, I'm going to give you your 1 minute. I'm going to give you your 1 minute. I gave you your hint. Think about what you might need to prove these triangles similar. I like the chewiness of these bars, but I can only take little bites while I'm teaching, because I got to talk, or while I'm doing a video because I got to talk. When I'm teaching, I might not be able to. I might not have to speak all the time. In fact, I shouldn't. So I can eat these during class, which is great. And there's our minute. There's our minute. A lot of students who think these triangles are not similar, they're going to end up being similar. Okay? There's two similarity relations. There's the angle similarity postulate. And then there's the side angle side proportionality. I want to put postulate, but a lot of textbooks say postulate. There's very few actual postulates in geometry, and so many of them are called postulates. And when they don't have to be, because they're not postulates, they're theorems, because they can be proved. But it's really theorem, okay? But sure, if your teacher says theorem. So what do you need for side angle side proportionality theorem? You need to prove that the angles, that one pair of angles are congruent, and then that two sides adjacent to that angle are proportional. So your cheat code here is ABE over ADC. Okay? ABE ADC. That's your cheat code right there. And so I have that A is congruent to A. Angle A is congruent to angle A. There's my angle. But unfortunately, because these sides are not parallel, and I don't know whether they're parallel or not, but I could actually visually see that they don't seem to be parallel, I probably don't have a second angle that I could easily prove are congruent. But I could check for drawn to scale. Well, let's see. The 5.6 and the 4.1. Half of 5.6 is 3.8. 4.1. No, 2.8. Sorry, 2.8. So the 4.1 looks quite bigger than 2.8, but not 5.6. That's drawn to scale. 3.42 looks smaller than the 4.1, but not half of it. I mean, close to it enough. The 8.22 actually, so these two add up to 8, a little more than 8, and 8.22 looks a little bit shorter than AD. BC looks a little bit shorter than the entirety of AD. This is definitely drawn to scale. I mean, 8.22 looks double to be a double AB if I cut this in half. This is drawn to scale. Drawn to scale, drawn to scale, DTS, drawn to scale. So I could assume that certain statements that look to be true are true. If you say yes, similar, you get a point. If you say no, similar, unfortunately, and you say nothing else, you don't get any points because these are actually similar. But notice that you could actually just coin flip and hopefully get a point, which means that guess at yes or no is worth half a point, statistically speaking. And you might not like statistically worth half a point, but we're working with statistics when we're doing guessing on multiple choice anyway. So you better actually like statistics with guesses. Turns out, yes, these are similar. So I have to use my cheat code. I have to check whether the corresponding sides, not including the bottom sides, because we don't have any information about these two sides. One arrow and two arrows representing that they're not parallel. So I'm going to use my not EB and ED. So I'm going to check AB over AD. Well, AB is equal to 4.1 over AD is actually parentheses 5.6 plus 3.42. The horizontal fraction bar doesn't need fractions, but your calculator isn't putting in horizontal fraction bars. Now, I will also recommend something to convert it into a fraction. So if you need to, if it's a long decimal, 6 plus 3.42. Let's see what it gives us as a decimal. 0.45 repeating. 0.45 repeating. So that's one pair of sides. One pair of sides is always proportional because it's just one pair of sides. You can put any numbers over any other numbers and say it's proportional. But now I have the second pair of sides, not EB, so I have to use AE. AE, that's first and third vertex. The other one I use 1 and 2 and 1 and 2. This one I have 1 and 3 and 1 and 3. So AE over AC, that's equal to, well, AE is 5.6 over AC is parentheses 4.1 plus 8.22. And by the way, I said approximately equal here, but in fact, in this case, it's actually exactly equal. So I'm going to use my calculator again to get this proportionality statement. 5.6 divided by parentheses 4.1 plus 8.22 close parentheses, and I get the same number again. Super duper. I get the same number again, which implies, so I could erase the approximately equal. It's actually equal to exactly 0.45. So now I have the sides are proportional. The difference between a ratio and a proportion is that a proportion is two ratios that are equal to each other. And these ratios are equal to each other. So I have to explain by the side angle side proportionality theorem. Triangle ABE is similar to triangle ABC. Do I have to use words and say by the side angle side proportionality theorem? Yes. You have to use words when they say explain. You don't have to use words if they say justify. You have to use words when they say explain. Have to. Have to, have to, have to. Number 30. Número 30. Determine and state the coordinates of the center and the length of the radius of the circle represented by the equation x squared plus 16x plus y squared plus 12y minus 44 equals 0. I will give you the minute, but if you already know how to do this, I'm going to wait maybe 10 seconds before I give an equation. Okay, that's my 10 seconds. I do want you to remember the equation of a circle with center HK and radius R. Let's draw that. Let's write that a little bit neater. Second. Is x minus h squared plus y minus k squared equals r squared. That's my hint for those who don't remember that equation. Notice that the coordinates of the center are subtracted. And notice that the radius is squared. Two places where students tend to lose points. Now, if you're wondering why in Algebra 1 we teach you how to complete the square, it's because in geometry you need it. And it turns out in Algebra 2 you need it. And it's one of those weird esoteric algebra skills that actually is relevant for pre-calc, calculus, and all of math. You kind of want to be able to convert expressions into perfect squares often, more often than you might expect. So determine and state the coordinates of the center and the length of the radius. So I'm going to make a table. I'm going to use a different color here. I'm going to make a table for the x direction and the y direction. And this is the procedure that I want you to use for completing the square every time. So first you get the number away from the constant term away from the variables. And you get, I'm going to write it this way, x squared plus 16x space plus y squared plus 12y space equals 44. Okay? And let me move this down a little bit. Okay? So this is the procedure I want you to follow. I want you to write the value of b. The b is the coefficient of x. So for in the x direction, b is equal to 16. b over 2 is equal to 16 over 2, which is 8. And b over 2 squared, go to your calculator, calculate 8 squared. Don't get this wrong. 8 squared is 64. A lot of students just get b squared wrong. So what do I do with this b squared? I take this b squared and I put plus 64. Plus 64 on both sides. Okay? And you might wonder why I did that. Let's talk about that in a second. For the y coordinate, I have b is the coefficient of y. So b is equal to 12. b over 2 is equal to 6. And b over 2 squared is equal to, go to the calculator again, 6 squared. A lot of students get this wrong, 36. So I'm going to circle this one, plus 36, plus 36. Okay? So again, why did I do that? Because I completed the square. This is a perfect square. So it's called completing the square because it used to be that x squared plus 16x was not a perfect square. But now x squared plus 16x plus 64 is a perfect square. And it turns out I use this number, the 8, to split it as a perfect square. And I got, it's an 8, that's a, b over 2 is 8, x plus 8 squared. And the same deal here. The y squared plus 12y plus 36 is also a perfect square. And I'm going to use this number here to write it as a perfect square. So plus parentheses y plus 6 squared equals, now all of this, 44 plus 64 plus 36. Go to your calculator to do it, or if you have a calculator installed, do it in your head, but confirm with the calculator. 64 plus 36 is 100, plus 44 is 144. Okay? But I would go to your calculator to confirm. And now we have the equation of a circle in standard form. Notice we're subtracting -8, so the center is x minus -8, so -8, and then y minus -6, so -6 equals this, and so that's the center. And then the radius, let's circle that. And then the radius squared is equal to 144. Take the square root of both sides, put the plus or minus, but it's a radius, so we reject the negative. Why? Because r has to be greater than 0. So r is equal to the square root of 144, which we go to our calculator. Turns out that 144 is a perfect square. R is equal to 12. And that is 2 points. 2 points for a 2-point problem, and with enormous amount of partial credit allowed. If you forgot how to complete a perfect square, like complete the square, but you do the same error twice, that's only -1. And then if you use that incorrect work to get a final answer, you get 1 point. So you can make one mistake and still get a point. Lots of places here where you can get a point. I know that this is one where there's a struggle, but there's other things that you could say. Since there's a plus 16x and a plus 12x, turns out that both coordinates of the center are going to end up being negative, which is rare for Regents. Often they purposely make it so that one coordinate is positive and the other coordinate is negative, but they didn't do that on this Regents. Again, really rare. Número 31, number 31. Another problem with a lot of partial credit allowed. If you just state the right answer and with some labeling, usually you can get partial credit, especially if you do some work. You can use the fact that it's drawn to scale to make assumptions, and it turns out sometimes you show enough to make it look like you made that you actually did the correct assumptions. And it does say determine and state. It doesn't say explain. So if you actually assume certain things, you can actually get full credit. This is one of those problems where you can assume certain things and get full credit. So in the diagram below, triangle SBC is similar to triangle CMJ, and cosine J is 3/5. Determine and state the measure of angle S to the nearest degree. I'm going to give you a minute. I'm not going to simulate me as a student by labeling. I want you to label as a student. They told you SBC is similar to CMJ. They told you cosine J is 3/5, and they want you to find the measure of angle S. Think about whether it's drawn to scale. Think about what you can say. Again, similar triangles, big deal. Okay? I'm turning my head to see perpendicularity, right? 30 seconds. Remember, humans are bred to be able to see perpendicular things when they're horizontal and vertical. When they're perpendicular but they're at an angle, it's hard to see. So it's hard to see if SC and CJ are perpendicular or not. If I turn my head so that CJ is horizontal and SC is vertical, they look perpendicular, or vice versa. If I turn my head this way so that SC is horizontal and CJ is vertical, then SC and CJ are perpendicular. Useful. Now, all the sides that look straight are straight. So I'm asking about similarity. Do these triangles look similar? So they said that SBC and C is similar to CMJ. So my cheat code in that order, CMJ. So they told us that that's true. So C on triangle SBC has to be congruent to angle C on triangle CM. Nope. Has the angle at C on triangle CMJ. So one arc. And B has to be congruent to M, and they're both right angles and they look like right angles. So that looks right. And then the angle at C on triangle SBC, so angle SCB, I'm going to put one dash on it, has to be congruent to the third vertex, J, angle J on triangle CMJ. Now, do they look similar? Well, S looks like the slightly smaller of the two angles than angle BCS on the left side triangle. And same thing, the angle JCM looks like the smaller of the two acute angles on the right side triangle. So these look like they're the right size. And in fact, if I turn my head and I say, well, SC does look perpendicular to CJ, these look similar. They are perpendicular, so they actually are drawn to scale. So I could actually make assumptions. I can say that, oh, and I'm sorry, drawn to scale, and then I have to check with cosine J looks like it's 3/5. 3/5 the adjacent side over the hypotenuse. So the hypotenuse divided by 2. So if the hypotenuse is 5x, then the half of that is about 2.5x, and JM, the adjacent side to J, looks like a little bit bigger than half of CJ. So actually, this is drawn to scale. The triangles are drawn to scale. So now I could make assumptions. The measure of angle S, that means that angle S actually has to be the smaller of the two acute angles, just a little bit. So the measure of angle S has to be less than half of 90, 45. Has to be less than half of 40, has to be less than 45, but perhaps by a little bit. Has to be. And this is a true estimate. So if I don't get a measure for angle S that's slightly less than 45, then I know I did it wrong. But if I get an angle that's really close to 45, but less than 45, then I know I did it right. How do we do this? The cosine of angle J is 3/5. So if I calculate the measure of angle J, that means that cos J is equal to 3/5. That means that J is equal to the cos inverse of 3/5. And I get to my calculator, they set to the nearest degree, but I'm going to give what the number on the calculator says. Okay, so cos inverse is right above the cosine. You see cos with a -1 exponent. So I'm going to actually take a screenshot of that. All the trig functions, all the three main trig functions have that right above the button. Cos and cos inverse, you see that cos inverse, so it's on your calculator, okay? So cos inverse, so you press the blue, in blue, so you press the blue second button, and then cos to get cos inverse of 3/5. Oops. And you get 53.13. Let's see, 53.1301. We talked about what I recommend, 10235. You might say, well, that takes a long time to write, but no, it doesn't. No, it actually doesn't. It takes you about 2 seconds, 2.5 seconds to write. Your writing speed is sufficiently fast. Actually, no, that's not true. If you write 1 character per second, it takes you have to write the 53 to 1301023. It takes you about 8 seconds to write that. Worth your time. If you remember to round at the end, it fixes a lot of problems. So the measure of angle J is equal to 53 that. So the measure of angle C is equal to 90 minus 53.13010235, which is equal to, and I should say that this is also rounded, so we should say actually approximately equal to. So 90 minus the answer, we could do second answer, 36 Now, if you're worried that I'm overlapping the old calculator screen with the new calculator screen, that's because both screens have all the information. 36.86989.765. Okay. So, but if I notice the problem already said, oh, and I said I shouldn't say C, it's MCJ. But I already said that angle S is congruent to angle MCJ. So the measure of angle S is approximately, and now I could round to the nearest degree, 36.8. I'm going to round up to 37. For 37. There's my answer. 2 points. And did I say it's a little bit less than 45? I did. So I got that right. Okay. Number 32, Nora 32. All right. So this is already, now we're at part 3. So this is the 4th of 5 times that they say this. Diagrams not necessarily drawn to scale. But I think the fact that they gave us one with a diagram, and we're going to talk about scale, is a hint. We haven't yet seen a single problem where the diagram wasn't drawn to scale yet. There's one that we might have had a little fight on, and a valid fight, I think. The one with the truck, wherever that was. And then there was this one where it was drawn to scale, except that the lengths are allowed to be whatever they want, whatever the problem wants them to be, or whatever the problem creator wanted them to be. So even though the diagram was drawn to scale, technically the length could have been anything. So if you want to accept that that one wasn't drawn to scale, I will actually support that. And if you want to say that this one's not drawn to scale, I mean, I might fight you with it, because the thing is that both people would be right. This diagram is actually drawn to scale because the perspective is skewed, but even though the perspective is skewed by putting the truck there, you actually can see the real life situation in a real life application. So if you want to say there's 2 diagrams on this test not drawn to scale, I'll disagree, but I'll support it. But like I said, there hasn't been a test that I recall with 3 diagrams not drawn to scale. So I'm still gonna stick to assuming things are drawn to scale until you confirm it. Or if you don't know how to do the problem, assume that they are drawn to scale, and use that if you don't know how to do the problem. Okay? So this one, 4 points. Plenty of partial credit to be gotten. Trish is a surveyor who was asked to estimate the distance across a pond. She stands at point C, 85 meters from point D, that's labeled for us, and locates a point AB on either side of the pond such that A, D, and B are collinear. They look like a perfectly straight line. Trish approximates the measure of the angle DCB to be 35 degrees, and the measure of angle ACD to be 75 degrees. Determine and state the distance across the pond AB to the nearest meter. So let's see. I'm going to give you the minute. Actually, I'm going to give you the minute. You do the labeling, because I don't want to do all the labeling for you right away. And then use that. Use that as best as you can, and use your calculator. Okay? 49 seconds. I'm going to show you a strategy that I use to maximize points by not having to round all the time. You saw me rounding all the time, not rounding all the time, but then putting a ton of decimal points all the time. I recommend now putting all the decimal points until the very end all the time, but I'm going to show you something you can do to not put the decimal points all the time. 27 seconds. 27 seconds. Make your estimates. Remember, you want AB. Okay. So if I'm making estimates, I usually check whether it's drawn to scale before I make my estimates. So there's nothing contradicting a length of 85. That's the only length that's given. This angle measures 35 degrees. They said that the measure of angle DCB is 35 degrees, and 35 compared to 45 is a little bit less than 45. B looks a little bit bigger than 45. DCB looks a little less than 45. That's drawn to scale so far. Then the measure of angle ACD, 75 degrees. That's a pretty extreme acute angle for a right triangle. And angle, the congruent pair for that one, the complementary pair for that one is angle A, which I'm going to put 2 dashes on. And that one is 75 minus 70, 90 minus 75 equals 15 degrees. Okay, equals 15 degrees. And that a 15-degree angle is actually pretty small. 15-degree angle, that looks like a pretty small acute angle. This is drawn to scale. This is drawn to scale. So I can use scale to make my estimate. So DB is a little less than 85 because it is drawn to scale, but then AD looks like 3 times bigger than 85. If I say estimate 3 times bigger than 85 plus another one that's slightly or less than 85, I could say 4 times 85. It's around 380. And I can't, like, it's hard to see 3 times versus 4 times bigger than something. So I'm not keen to say whether it's going to be way bigger than 380 or, I'm sorry, a little bit bigger than 380 or a little bit smaller than 380. But my estimate for the length in meters, they did say meter, right? They said the estimate, my estimate for the length in meters is 380, but I don't know if it's bigger or smaller, but it's got to be a good estimate because it's drawn to scale. So Trish approximates the, let's see, so how do I actually go about doing this? So I know that the side adjacent, so these two are right triangles, they're both right triangles. So on triangle ADC, the 85 meters is equal to the side adjacent, the leg adjacent to the angle, the 75-degree angle. Okay, and I should also say that what I'm going to do is I know that I want AB, but I know that AB is equal to AD plus DB. So if I find AD and I find DB, I got my answer. Okay, so 85 meters is the leg adjacent to DB, and also AD is equal to the leg opposite to the 75-degree angle. Opposite and adjacent, that sounds like a tangent. So that is a tangent, in fact. So tan 75 is equal to opposite AD over adjacent 85. I could put this over 1 and cross multiply. Like I said, I'm not a fan of cross multiplying in some situations, although I teach it that way now. So I got 85 tan 75 is equal to 1 times AD, which is just AD. So 85 is equal to tan AD. That's part of my answer. Okay. And I'm going to, the hint to not have to round early on or to not have to write a bunch of decimal places early on is you could just leave it that way, 85 tan 75, and then use it that way. Now the next part to get DB, I know that again, AD is 85 tan 75. I'm going to leave it that way. Now, in triangle BDC, I know that 85 is also equal to the leg adjacent to the 35-degree angle. And I know that DB is equal to the leg opposite to the 35-degree angle. So again, it's tangent. Tan 35 is equal to opposite DB over 85. Now, for those of you who are wondering what I would do if I didn't cross multiply, again, I highly recommend cross multiplying. And I've become a big fan in terms of fixing cognitive dissonance, but I could also just multiply by 85. Just for teaching and completeness, 85. So I get that dB is equal to 85 tan 35. So 85 tan 35. So then what is AB? AB is equal to the red length, 85 tan 75, plus the black length, plus 85 tan 35. And I add these two numbers, and according to my calculator is 376. And again, just put that in your calculator as is, 376.74, 19594. And then AB is approximately that. And then now I go to see what they said to the nearest meter. AB is approximately, let's see, the 7 causes us to round up. So I got 3, 7, the 6 rounds up to a 7. Do I put the units? They gave the length in meters, and the final length is in meters. I don't have to put the units, and I actually recommend avoiding it if they gave you the units. So that's how to do that one. Not bad. If you need a break, by the way, this is a long video. I would say you could pause the video, get water, whatever you need to do, get a snack. I'm going to keep going. I've got this little bar. I got my coffee over here. This one is not decaf, but if you're not used to drinking coffee, I recommend not starting the day of the Regents. But you can bring decaf, and I recommend putting some lactase powder in there if you're even remotely suspected to be lactose intolerant. But I would, even if you don't need the coffee, I would recommend not using it. So this one has a 2-part problem, so we're going to take 2 little mini breaks. This is still a 4-point problem. I wanted to talk a little bit about partial credit for this one. This is a 4-point problem. There is so many places where you can get partial credit. Again, 4 points. If you get to the final answer using all correct math, you get full credit. And it's almost unavoidable that if you get the final answer, you can get full credit. You can't lose points. But if you do one incorrect mistake to get like AD, but you make the same incorrect mistake to get DB, depending on what the error is, you might only lose 1 point, or you might lose 2 points. But if you make the same error twice, they don't penalize you. So like, let's say, for example, if you use cosine instead of tangent, you only lose 1 point. If you use tangent instead of sine, I'm sorry, if you use sine instead of tangent, you only lose 1 point or 2 points. I don't remember. I could check 1 point or 2 points. But if you do it twice, you only lose 2 points max. But if you get your answer based on that, you get 2 out of 4 points. How many multiple choice questions is 2 points? It's a full multiple choice question. So why should you show all work and do as much as you can on the part 2s, 3s, and 4s? Because if you get if you get partial credit on this one, you can get a full multiple choice question for free, or half a multiple choice question, which is a point, or 1.5 multiple choice questions, which is 3 points. Or you might accidentally find out that you actually just know how to do the problem, and suddenly you just number chase until you get the final answer, and suddenly you're done with a problem you didn't know you knew how to do. If you can get part of the way through, you can get partial credit. The only thing required for partial credit is you have to get to a final answer on each individual part. If you get to a final answer on each individual part, that's partial credit. If you get, so even if it has a mistake, if they said to the nearest meter, but you didn't round to the nearest meter, that's partial credit. And rounding errors are only 1 point off. Now, number 33, número 33. Let's do this one now. Okay, a candle in the shape of a right pyramid is modeled below. It's a candle, okay? Each side of the square base measures 12 centimeters. They tell you it's a square base, measures 12 centimeters, and the slant height of the pyramid measures 16 centimeters. Part 1, determine and state the volume of the candle to the nearest cubic centimeter. Part 2, the wax is used to make a candle that make the candle weighs 0.032 ounces per cubic centimeter. Determine and state the weight of the candle to the nearest ounce. Okay. So I'm going to give you a minute for the first part, and I'm actually going to give you a minute for the second part. Because it's 2 points and 2 points. 2 points and 2 points. 50 more seconds. $35 seconds. $15 seconds. 5 seconds. If you appreciate what this video has done for you, again, all I ask you is for just to hit the subscribe button. I do not post a ton of videos, but do the subscribing allows me to at least earn a little revenue, not from you, but from watchers of the video. So I do appreciate that part of it if you do appreciate what is being done in this video. Now, the first part of this, determine and take the volume of the candle to the nearest cubic centimeter. So this is a situation where students lose points from this problem just by not bothering to look at the formula sheet. Sometimes it's not applying the formula sheet correctly, but this one, like this is the formula sheet: triangle area, parallelogram area, circle, circumference, a prism volume, a cylinder volume, a sphere volume, a cone volume, and a pyramid volume. Here's a pyramid volume right here. Okay, so just by going to the end and getting the formula sheet, you probably will get partial credit. If you just go to the end, you probably will get partial credit. Okay, so how do I determine and state the volume? Now it says determine and state. If it just said state, you could just give the number and you're done. But it says determine and state, so which means you have to do some calculation. One great thing about it, if you don't know how to get, if you happen to recognize that the 16 is not the actual height of the pyramid, because it's missing some sides, but you accidentally, so if you happen to recognize that, and why didn't it straighten that one? Okay. But you use that length 16 as the height anyway, you actually get partial credit. If you didn't realize and you use the 16 as the height, you get partial credit. You get a point if you get the volume right. If you get the correct height, but you don't get, if you don't do the rounding correctly, or if you make a mistake in calculating the height of the pyramid, I need a different color than that, then you can get partial credit. There's a lot of partial credit that it can be given in this problem. Okay, so that right there is the center of the base. And then I'm going to make a line right there. And notice that this makes a right triangle. A right triangle. But not only that, if I keep extending this red line segment all the way to the other side of the base, now I have a length of 12. And since it's a right pyramid, that means that that center is at the center of the square, which means that this length is 6 and this length is 6. So that red line segment is length 6. I have two sides of a triangle, I can get the third side. I have two sides of a right triangle, I can get the third side. I have, so the h is the height. I know that a squared plus b squared equals c squared in a right triangle. If I make the estimate slightly less than 16, I don't know, 14 for the height, and then I can get a volume. I could do 1/3, 12 times 12 times 14. That's an estimate. Now I know if I get an answer very close to that, I can get the right answer. Okay, or that my answer is correct. And I go to my calculator to do this estimate. So this is 36 times 14, whatever that happens to be. 360 times 15-ish. No, 48 times 14, which is then I could do 50 times 13 or something like that, whatever I wanted to do. 50 times 13, which is 10 times, 100 times 7.5, 750-ish. That's my estimate, but it's a good estimate. Now, I just use skills in estimating that I personally have. I don't expect you to use the exact same skills that I used, but 14-ish and putting that in your calculator and see what your calculator says is a great way to do it. So I see that the height is one of the sides. So I got h squared plus the leg is 6 squared, and that's equal to the hypotenuse, which is 16 squared. So h squared plus 36, according to my calculator, is 256. Subtract 36. Subtract 36. I get that according to my calculator, h squared equals 256 minus 36 is 220. Okay, so the h plus or minus reject. Now in this geometry problem, we've been rejecting the negative sign, the negative one, because in all of these situations, the number has been greater than 0. I don't want you to think that that's always the thing you reject, but it does turn out in geometry almost every time you reject it because the number happens to represent a length almost every time, but it's not always true. And in algebra 2, it's true less often, but you often do reject the negative sign because the h is greater than 0. So h equals radical 220. Now I'm actually going to keep it that way because I need to get the answer to the nearest cubic centimeter. I know that the volume is equal to 1/3 base times height, which is equal to 1/3 12 times 12 times the height is radical 220. And then I'm going to use my calculator to get that number. I don't need to do what I've seen students do, radical simplifications. They don't care that you know how to do radical simplification. We cared in middle school because you kind of need to know what radicals are. We don't care in this class. 12 times 12 times radical 220. The volume is that number. And our volume was 750-ish, and our volume turns out to be 711.9550548. So the 9 causes to round up. So the volume is approximately 712 cubic centimeters. Okay, cubic centimeters. Now I do want to give you another minute to look at the second part of this, because it is a second part that you get a lot of partial credit on. Oh, no, I don't want to do that. So the wax used to make the candles, let's delete that so it's easier to see. You don't have to circle your answer, but it is not the worst thing to do. The wax used to make the candle weighs 0.032 ounces per cubic centimeters. Determine and state the weight of the candle to the nearest ounce. So I'm going to give you the minute. And I'm going to give you the hint that they do in math tests. They used to give unreasonable questions and tests back in the day, like a cantaloupe weighs 57 kilograms, or like a watermelon weighs a milligram, or things like that. An orange with a radius of 5 feet, like things that didn't make sense. They no longer do that on these tests. You got 27 seconds. So why am I mentioning that? I know that wax is a pretty light chemical. So I expect the weight to be pretty small in ounces. There's 16 ounces in a pound. So I'm going to let W for the second part. So that was the minute. I'm going to let W equal the weight in OZ, in ounces. Okay? Now, I learned in the wording of the problem that the wax used to weighs 0.03 ounces per cubic centimeters. So I'm going to use the part over whole proportionality relation. So, and in this case, the part on the left side, I'm going to use the part on the left side. So I need the weight in OZ, which is a mystery number, divided by the volume is equal to the weight of a known quantity. So this is actually the part over known proportionality relation, except that we're doing the part and the known on the left side. So the weight over the volume, that's equal to 0.3032 ounces, 0.032 ounces. That's the weight over 1 cubic centimeter. And now I'm going to cross multiply. So I got the weight times 1 is equal to the weight, the volume times 0.032. So I got the weight is equal to the 712 times 0.032, which the calculator is going to give me a number. 712 times 0.032. And now I said, remember the hint that I gave you, weight is going to be a pretty small number. Okay? So equals approximately 22.784. They said to the nearest ounce. So weight is approximately 22.7. The 7 causes us to round up. 23 ounces. 23 ounces compared to 712 cubic centimeters. 23 ounces is about a little less than a pound and a half. So we're going to move on to number 34. This is the first problem. I'm going to give you a minute to work on the problem after I give you the very first step, because the very first step, unfortunately, doesn't give you any points. But you can, this is my hint. So I've heard teachers tell students, skip the proof, skip the proof. That is probably one of the, and teachers, I'm sorry if you did give that advice to skip the proof, skip the proof. That's actually one of the worst pieces of advice we could give to students. And students who are telling that to each other, that is actually not good advice, because proofs, even if you can't get to the final answer, proofs are actually partial credit friendly. And proofs are almost always a 4-point or a 6-point problem. If it's a 4-point or 6-point problem, then you can get 1, 2, 3, or 4 points just from the friendliness of the partial credit. The only problem is that they don't really tend to give you points for the givens. They used to, but not really anymore. And it really depends on the problem. And I don't know if this one will give you points for the givens, especially depending on the way you write it. But let's talk about partial credit, but let's see how far you can go giving statements and reasons. Just remember, always give reasons that are valid with statements that are valid. And you don't even have to necessarily know how to get to the final answer. Just give statements and reasons that are valid. So in the diagram of quadrilateral ABCD below, AB is congruent to CD. Now I'm simulating myself as a student for the purposes of this one. AB is congruent to CD because of the fact that I'm giving you the first step. AB is congruent to CD. Then AB is parallel to CD. That's a big deal. That sounds like something that's very, very, very important. And then segments CE and AF are drawn to diagonal BD such that BE is congruent to DF. Prove that CE, eventually we want CE congruent to AF. I've seen a lot of invalid proofs here, but remember this is a 4-point problem. It's going to take a few steps. So why am I giving you the first step? Because a lot of students don't even bother writing the first step. And there's so much partial credit here. Like if you write the first step, which is the givens, you often can just get to something because you kind of remember something in class, that kind of thing. So statement and reason. And so the first step is just the given statement. Okay? So quadrilateral. A, B, C, D. And then AB congruent to CD. And I labeled that stuff on the diagram. AB parallel to CD. And then segment CF and AD and CE and AF are drawn. That's just a drawing. Okay, to diagonal BD. They told you that BD is diagonal, maybe as a hint. But they don't have to say it as a hint since BD connects. B and D connect each other. Maybe just to imply that those are straight lines. But again, but also BE is congruent to DF. And all of those are givens. If you just write the given information with the reason given, that's usually 0 points. But there's so much information that we just gave. I'm going to tell you the only way to get partial credit is given a correct statement with a correct reason. It turns out that they kind of start allowing, they never give you half a point, but they can give you a point if you do something like maybe give two statements that are correct without correct reasons. So just give as much as you can. And if you do give a correct statement and a correct reason, that's a point. That's a half a multiple choice question. Give 2 statements with 2 correct reasons, 2 points. Give 3 statements with 3 correct reasons, that's 3 points. And then finally, the fourth point, you just need the final correct answer with all correct statements and reasons. Okay? So I'm going to give you your minute now. This is where I'm going to give you your minute. Do what you can. There's a lot of structure here. See if you can give correct statements with correct reasons. And if you can't give correct statements with correct reasons, try to see if you can give correct statements. Lots of partial credit. Lots of partial credit. 38 seconds. Little itty bitty bite. Bar is so chewy. I'm like, ah. But I hope you were able to get some partial credit. All right. So anything that you could say that is true based on the information that's given with a correct reason is points. So you may remember that if you just have a quadrilateral, and I will say this, I'm sorry, I will say this, not all of these statements have to be given in the exact order that I gave them, but there are a lot of valid ways to do this problem. Okay? So the order can be changed. So if you happen to recognize, so back to the actual proof, okay? If you happen to remember that if you have a quadrilateral with one pair of parallel sides, and that same set of parallel sides are congruent, and you actually have a parallelogram. Quadrilateral, so statement 2 is going to be that ABCD is a parallelogram. You are allowed to use that symbol for the word parallelogram. ABCD is a parallelogram. Y, that is a quadrilateral. And do you have to write all this out? Yes. So a quadrilateral, and you could just say quad for quadrilateral. Shorthand is okay, as long as it's not obscene, with one pair of opposite sides, that is both parallel and congruent, is a parallelogram. Again, some symbols here. This symbol, parallelogram, they allow that. This symbol is parallel. And this symbol is congruent. And there's other symbols that you need, similar. But we're not using it here. Perpendicular. But we don't need either of these. I'm just commenting just for extra. And I'm probably going to delete them in a second, okay? Because I'm going to need space. Proof tends to be long. So these are, this is a parallelogram. So, what can we do with this? So, I'm going to use the fact that this is a parallelogram. There's another proof that doesn't use that this shape is a parallelogram. I may verbally just mention it later, but this is the way that I decided to go. So that's what I'm going to do. Okay. BC is congruent to DA. So I'm going to prove what my goal, just so you know, I'm going to prove that this top triangle and this bottom triangle are congruent. That's just the way I saw it when I first did it, which is why I'm going for it. There's a shorter proof, but a lot of students struggle with it so much so that I decided I think this is also the better way to go about it right now. So BC is congruent to DA, but why? I'm going to put 3 dashes here because opposite sides of a parallelogram are congruent. So that's already 2 points. 2 points. Sweet. So I got, for the top triangle and the bottom triangle, I actually have 2 pairs of sides. So now I'm going to erase this because I do need space for this giant proof. Okay. So I'll go back to statement and reason. Okay, so what do I do next? I see that if the top and the bottom side are also going to be parallel, why do I want to use parallel? Because I need a pair of angles congruent. So BC is parallel to DA. And the reason for this is that opposite sides of a parallelogram are parallel. But that allows me to make these angles right here. This angle, which I've drawn with an arc, and this one with an arc, they're going to be congruent. So angle CBE is congruent to angle ADF. Why? Because alternate interior angles are congruent. Alternate interior angles, they make a Z. They're congruent, okay? Which makes, by side angle side, it makes that green triangle and that other green triangle congruent, 6. So triangle CBE is congruent to triangle ADF by side angle side. Congruent to side angle side. Okay, which now that allows me to say that all parts of these two green triangles are congruent, including IV, IV. Okay, that AF is congruent to CE, which was my eventual goal, wasn't it? AF is congruent to CE. They're parts of the corresponding parts of the congruent triangle. So, so one last statement, 7. I know you see a lot of students say CPCTC, and you don't know what that means. You should never use CPCTC if you haven't yet proved that two triangles are congruent. Vice versa, the moment you have that two triangles are congruent, you could use CPCTC all over the place. It says corresponding parts. Parts of congruent triangles are congruent. Oops. T. Sorry about that. Corresponding parts of congruent triangles are congruent. Let me erase that. Let me put that at the end so you can see it more properly. So where do the letters come from? C, P, C, T, C. Corresponding parts of congruent triangles are congruent. C, P, C, T, C. Okay? And you're done. We're done getting the thing that they wanted. So that is a 4-point proof. Is there a shorter proof? Yes, and technically there is a shorter proof, and some teachers prefer it because it's shorter, fewer steps. Is it easier? I would argue that it's not necessarily easier. Some of these problems allow you a lot different methods to get the problem right. But what is the shorter one? Well, since BE and DF are congruent and EF is congruent to itself, you have to put as a step EF congruent to FE by the reflexive property. And so then BE plus EF is congruent to DF plus EF, but it's a plus FE by the addition postulate, and that makes BF congruent to DE. And then you could use alternate interior angles using the sides that are parallel already to prove that angle ABF is congruent to angle CDE. Never needed the fact that these are parallelograms, but I think that's one less step, or not, depending on how you write it. So I don't know that that's necessarily better. And as my students know, I do not call any one method in math better than any other method in math. Just different. And the reason I like having more than one method in many situations is that having more than one method, what that allows you to do is apply different methods in different situations in which one method doesn't apply but the other one does. So having more methods is actually the plus, not having one method because it's better than the other. All right, numero 35, number 35, and the very last problem. And now this one doesn't have any diagrams drawn except for the axes. So I guess I can say that this one has a diagram drawn. The axes are drawn. All the numbers seem to be in the, like all the squares seem to be squares. So good. So, but I want to reiterate that this is actually the 5th place that it says diagrams not drawn to scale. Diagrams not necessarily drawn to scale. Okay. They say it 5 times on this test, except that we went through a whole test where, depending on how much you want to fight Kumite style, you might want to say that some of the diagrams weren't actually drawn to scale. 2 of them maybe, but the thing is that there's arguments that they were totally actually drawn to scale. The only thing about that one diagram where some of the line segments could have arbitrarily been longer or shorter is that in that diagram, well, we could have changed the size, but they kind of made them look like they might be the same size. The other one was the one with the truck. Well, the one with the truck, because they looked at it at a skewed angle, the 30-degree angle looked like it was bigger. And if you erase the truck, well, that angle is now just a triangle with a right angle that didn't look like a right angle, and a 30-degree angle that looked too big. But again, the skew made it, with the truck picture there, made it actually look like it's to scale. So I think there's a valid fight. So this test had somewhere between 0 and 2 diagrams not drawn to scale, with very valid arguments on either side. And again, not 3. I still haven't seen a test with 3 diagrams not drawn to scale. With so many diagrams in a geometry test, it's clearly safer to assume that a diagram is drawn to scale than it is to assume that it's not drawn to scale. And even better than that, as a test-taking strategy, assume it if you can't figure out anything. But a better test-taking strategy, confirm it. Because if it is drawn to scale, you could just use the scale to eliminate a ton of choices or make predictions on a part 2, 3, and 4. Number 35, number 35, quadrilateral math, MATH, has vertices with coordinates -1, 7. They say use of the axes is optional. Use them. You can get partial credit. M, -1, 7. A, 3, 5. T, 2, -7. H, -6, -3. Prove that quadrilateral MATH is a trapezoid. Important things. If you're going to use the axes on the part 1s, no one's looking at your work, but you still have to show work to maximize your points. But on the part 2s, 3s, and 4s, they're going to look at your work. You have to use a ruler for a straight line. You have to use a compass for a perfect circle. Okay? So I need to, and your graphs have to be accurate. So -1, 7 for M. 3, 5. It has to be at that point. Okay? And I put some dashes there at 5 and -5 to help me look. Do you have to label the numbers? No. Because if the numbers aren't labeled, you can assume that they're skip counting by exactly 1. If you're skip counting by anything other than 1, then you have to put the numbers. And if they're skip counting by 1, you don't have to put the numbers. But you do have to label the axes, but they're labeled for us already. A is the 0.35. T is the 0.2, -7. H is the point -6, -3. Okay? Now, notice that my points are actually labeled exactly at the intersection of 2 segments. The second thing is when you draw your lines, I have software that allows me to draw perfectly straight lines. Look at that. You don't have software, but you have hardware. You have a straight edge. So if your question is, do you have to use a straight edge to draw the lines perfectly straight? The answer is yes. And I recommend it because then there's a lot of hidden information that kind of pops out to you by drawing with your straight edge. Okay? So now I can label the points M, A, T, H. And I that's a lot of work. There's a lot of things that you could do to get partial credit. You're allowed to answer this question using the graph only. You're allowed to do that using the graph only. So for example, if you could say that the slopes are the rise and the run is 2 and -1, and here the rise and the run is 2 and -1. So the lines have the same rise and run. That's 2 points in the first part. I'm going to do the calculation because I promised that I would do the calculation for all of them. So the slope, so what is a trapezoid? A trapezoid has 1 pair of parallel sides. I want to point out that I did not say exactly 1 pair of parallel sides. A few teachers are holdouts on saying that a trapezoid has to have exactly 1 pair of parallel sides. No, it has to have 1 pair of parallel sides, and it could have 2, which means a parallelogram is a trapezoid. This is clearly not a parallelogram because it doesn't have 2 pairs of parallel sides, but a trapezoid has to have 1 pair of parallel sides. And in fact, I could see visually that MA has to be the one that's parallel to TH because MH is not visually parallel to AT. Now, the benefit of using the graph? I'm not going to check the slope of MA, of MH and AT, not at this point, because it would be a waste of time. I know that MA and TH are going to be the ones that are parallel. So the slope of MA is equal to, remember the slope y2 minus y1, x2 minus x1. That's the formula. So 7 minus 5 subtracting the y coordinates divided by subtracting the x coordinates, -1 minus 3. And I can go to my calculator if I wanted to. 2 over -4, in which I can go to my calculator again and convert this into a fraction, -1/2. I actually think I want to show you how to do this on the calculator. Calculator, you need parentheses. On paper, because it's a horizontal fraction bar, you don't. Horizontal fraction bar, you don't need parentheses. Vertical, diagonal fraction bar, you do need parentheses. Division is not a grouping symbol. Horizontal bars are grouping symbols. In fact, fun fact, the horizontal bar in the radical and the horizontal bar in the fraction are the same symbol. The radical symbol initially was literally two symbols put together, that little V hook and then a horizontal bar. And the horizontal bar is called the vinculum. So you need the parentheses, 7 minus 5. Close parentheses divided by -1 minus 3. Got -0.5. And I'm going to convert this into a fraction. Math, arrow frac. That's how I did it. Okay? Press the math button, arrow frac. -1/2. Okay? So you can do that on the calculator. Now I'm going to get the slope of TH is equal to, again, y2 minus y1 over x2 minus x1. I don't like the fact that I use the same symbols here because maybe y4 minus y3 over x4 minus x3 is a better way to write it. But I'm writing it just as the formula so you catch the pattern. That's why I did it this way. Okay, so -3 minus parentheses -7 divided by -6 minus 2. A lot of students get this wrong by not putting the parentheses around the -7. Another thing, a lot of students get it wrong by not remembering that minus and negative, both negative signs are necessary. And another way that students get this wrong is when they put it in the calculator, they don't use parentheses. So this one, I promised that I would do this on the and fully, but if you put it on the calculator, make sure to put parentheses around the numerator and parentheses around the denominator. -3 minus 7 is -3, minus -7 is -3 plus 7, divided by -6 minus 2, I could just do -8. And the numerator, 7 minus 3 is 4 over -8, and that's equal to -1/2. So I get the same slope. So now I have the slope of MA is equal to the slope of TH, and I should say actually one pair of parallel sides. So MA is parallel to TH. Therefore, MA, TH is a trapezoid. Nice. Okay, so I do want to give you another minute to try the second one. That's 2 points, by the way. This one is a super generous multiple choice partial credit problem because of the fact that it has multiple parts. Because of the fact that it has multiple parts, you can get 2 points for the first part, 2 points for the second part, 2 points for the third part. If you don't get the answer for the top one, but you figure out how to get 2 points for the second one, and you figure out how to get 2 points for the third one, partial credit. Lovely gift that a lot of teachers and students didn't notice. This one, part 2, says state the coordinates of point Y such that point A is the midpoint of MY. You just have to state it. And if you state it, you get the partial credit. Okay, so I'm gonna give you in this case 30 seconds to state the coordinates of point Y, because it's just you either see it or you don't type of thing. But you could use the graph and you can get partial credit. You can get full credit by using the graph. And you can also get full credit by doing the algebra. I'll give you 20 seconds. No, 10 seconds. Okay, so the next one, I better scroll down a little bit. I'm going to state the coordinates of point Y such that A is the midpoint of MY. Okay? So how do I do that? I have to get A to be the midpoint. So now some students get this wrong by getting the midpoint of MA, but in fact MA we're not getting the midpoint of MA, or vice versa. Because M the word M starts with the the word midpoint starts with the letter M, and often we actually name midpoints with the letter M. What we end up doing is let M be the midpoint, but in fact, they said A is the midpoint, okay? A is the midpoint. We need a point Y. It's going to be right there. So another way you could do it with the graph, you could go to the right 4 and down -2. And if you go to the right 4 and down -2, that's point Y. And now you have to state the coordinates. That's 7. That's 3. 7, 3. And if you write it next to that, and you put it here, 7, 3, you get full credit for that part. Okay? They just said state it. But I'm going to actually do the calculation because I promised that. If I call this the point X comma Y, I'm going to use the midpoint formula. A is the midpoint. So A is equal to X1. So, well, the midpoint is going to be, what's the coordinates of A? Again, 3, 5 is going to be, so now that I've graphed it, I can confirm whether my work is correct. Okay, so this is going to be equal to the midpoint. It's going to be X1 plus X2 over 2, parentheses, comma, Y1 plus Y2 over 2. And so now I just plug in some numbers. So I got 3, 5. And by the way, if you give a point, but you don't give the parentheses, unfortunately, you do lose points. They call that a conceptual error, so you need the parentheses around the point. So X1 plus X2, now these are the coordinates of M. M is -1, 7. So -1 plus this mystery X2, Y2, over 2, comma, Y1, 7 plus Y2 over 2. Okay, so now I have two equations. So 3 equals -1 plus X2 over 2 times 2 times 2. That's 6 is equal to -1 plus X2. I cancel this -1 plus 1 plus 1. I got X2 is equal to 7. And now my work is looking very good. And now, so we have a little differentiation in color here. Let's get the Y coordinate. We have 5 is equal to the Y coordinate of the midpoint. So 7 plus Y2 over 2 times 2 times 2. We get 10 equals 7 plus Y2 minus 7 minus 7. We get that Y2 equals 3. And we get, so the coordinates, 7, 3, as we suspected. And that's a bunch of points there. Now, for part 3 and the end of the test, we are almost done. I'm going to move this all down. What just happened there? What just happened there? That's weird. Okay, so I'm going to move this here. Okay, you know what? I'm going to leave that where it is. Unfortunately, it's being buggy. It wasn't being buggy earlier, but I think I know why it's being buggy. But it says to prove that quadrilateral MYTH is a rectangle. Prove that quadrilateral MYTH is a rectangle. So now I'm actually going to finish off quadrilateral MYTH with a straight edge. And I have software to help me do that. Let's see if it straightens that out. Yeah, that's a little bit too bent. Okay, let's try it this way. So now this does, if I turn my head, it does look like a rectangle. And what do I know about rectangles? Well, they're parallelograms. So if I do the work needed to prove that this is a parallelogram, I haven't done the job. So I can't just prove that the opposite sides are parallel, because we already, it implies, oh yeah, we can't just do that. But if we prove that opposite sides are perpendicular, I'm sorry, if we prove adjacent sides are perpendicular, then we've proved that it's a parallelogram. Another way to do it, not the way I'm going to do it, if we prove that the diagonals are congruent using the distance formula, then we've proved that the quadrilateral is a parallelogram. So we already know that MY is parallel to HT because MA is parallel to HT. Okay, so these opposite sides are parallel. So this thing is at least, that's at least true. And so if you have parallel sides that are each, if one of them is perpendicular to the other, if one of them is perpendicular to something, then the other one is also perpendicular. So we don't have to prove everything's perpendicular to everything else one step at a time. We could just prove one at a time and then use that to prove another one. So how do we prove perpendicular lines? Have opposite reciprocal slopes. Okay? Perpendicular lines have opposite reciprocal slopes. Alrighty. So that's what we're going to do. Perpendicular lines have opposite reciprocal slopes. And so we're going to show that MA, our goal is to prove that MH is perpendicular to HT. And that also that makes, okay, so let's actually start there. That the adjacent sides are perpendicular. So we're going to get the slope of MY. The slope of MY, we've already done the work, is equal to -1/2. Now we're going to get the slope of HT. The slope of HT is also equal to -1/2. We've already done that work. Okay? So what about the slope of H? So we better get the opposite reciprocal of that. The reciprocal is -2. The opposite of that is 2. So we better get 2 for this slope. They told us that it is a rectangle, and we're trying to, myth is a rectangle. We're trying to prove that it's a rectangle, so we better get a slope of -2 for HM. And so that's equal to, again, y2 minus y1 over x2 minus x1, which is equal to -3 minus 7 over -6 minus parentheses -1, which is equal to -10 over -6 minus -1 is -6 plus 1. We can go to the calculator. In fact, we could go to the calculator at this point with parentheses and get a slope of -10 over -5, which is equal to 2. I only did this on paper because I promised I would, but I would go to the calculator every time. But this proves that HM has a slope that's opposite reciprocal to HT, so that HM is perpendicular to HT. Okay, and also that HM is perpendicular to MY. Now we could prove the other pair. So we prove those. Now we could prove the final pair perpendicular by getting the slope of TY. No, TY is equal to, our goal again is to prove that this is going to be equal to 2. So y2 minus y1 over x2 minus x1 equals 3 minus parentheses -7 over 7 minus 2 equals, you can go to the calculator with parentheses, or 3 plus 7 over 5, which is 10 over 5, which is equal to 2. Now that slope is opposite reciprocal, therefore TY is perpendicular to HT, and TY is perpendicular to MY. So we've proved all 4 sides are perpendicular to each other. So a rectangle with 4 perpendicular sides is a quadrilateral. We don't know that it's a rectangle. A quadrilateral with 4 perpendicular sides is, now we do know it's a rectangle. Guys, that is the end of the video. I hope you stuck to it all the way through the end. Again, normally my videos are 3.5 hours. This one is about 5.5 hours long because I decided to skip the editing, which normally takes 7 to 12 hours, and sacrifice that for 2 more hours of talking with more hints and more questions answered. So I am done. I'm gonna stop recording, and I'm gonna leave this as is. All coughs, all errors, all whatever. There are no errors other than that number 5 that I made an error on in my estimation that I fixed in the end. And then a couple of times I misspoke that I fixed. Everything that I fixed is 100% correct. I confirmed with the answers online. I did everything that I needed to make sure everything was correct. So I'm glad that you stuck with me. Please do hit the subscribe button if you appreciated it. Do check the description below for any links to any additional information. I am going to create a document between now and the end of next week as a study guide for students and for math teachers for what exactly like the 35 sheets to study to practically ace this exam. Like if you can get everything right on all 35 sheets, you can ace this exam. All right. And that's it. I'm going to just stop there. Thank you for watching and feel free to comment any questions, comment your appreciation. Make sure to say thank you to Jelly, the moderator, for moderating this.